So good morning, everybody. Sorry for the delay, and welcome to Code Dive. My name is Remigiusz Marciniak, and today I will be the host of this room of the Venus. The room Venus is dedicated to machine learning and human skills. We'll kick off the day at 8:45 with Wojciech Plans and Wojciech Maciantowicz's presentation. The final lecture will be conducted by Viktor Kirillov and will conclude at 6 p.m. Throughout the day, we will have three breaks, including 2 coffee breaks and 1 lunch break. The coffee break will last 30 minutes each. The first coffee break starts at 10:30 and ends at 11, while the second one begins at 14:35 and concludes at 15 past 15. Our lunch break will be from 12:45 to 14. If you are hungry, you can purchase Pan Pretzel, which offers both sweet and salty options, on the ground floor and second floor. Additionally, coffee is available on the ground floor. There are plenty of restaurants nearby where you can enjoy a delicious dinner. We would like to express our gratitude to our partners for this year's edition. The Protocol, Pasja Informatyki, Talenty, Mamo Pracuj, Test Dive Conference, Programista Magazyn, Wrocławski Park Technologiczny, Challenge Rocket Helion, and Women of IT. We would like to invite you to the Women of IT conference, which will take place online in Bydgoszcz on November 23rd. Today's edition holds a special significance for us as we celebrate the 10th edition anniversary of the Code Dive conference. To mark this milestone, we have expanded to 4 conference rooms filled with inspiring and top-notch lectures presented by global experts and our local talents from Wrocław. The central theme of the 10th edition is the fusion of the space industry with the tech industry. Most of the space theme lectures will be held in the Moon Room on the ground floor. There, you will have the opportunity to learn about building LTE systems on the Moon, explore embedded systems in space, discover how Rust is used for space exploration, and understand what it takes to work in the space sectors. All lectures will be recorded and made available on YouTube. So if you miss any sessions, you can catch up later. Attention, at the Nokia booth you will find a crossword puzzle, so solve the crossword and drop it in the ballot box. Prizes will be provided for the drawn winners. It will be a Lego set. Okay, and this year's attractions are the space-themed games that you will find in the hallways. So it will be a movable platform 5D, VR, a Cosmic Roller Coaster, Cosmic Flipper, Star Trek, arcade, space games, and reflexometer Cosmic. But the biggest attraction is as many as 4 rooms filled with content-rich lectures. Another important information is that after each presentation there will be a QR code where you can rate the speakers, and then after the conference there will be an opportunity to win a voucher to a Vinci power nap. And another quite sad information is that there is a broken pipe nearby, so the toys will be available on the back door, and then hopefully the city will fix this broken pipe. And thank you very much for joining us, and we hope we have a fantastic and enlightening experience at Code Dive 10th anniversary edition. And right now, allow me to introduce our next speakers, Wojciech Plan and Wojciech Maciantowicz. Wojciech Plan is an empowering leader with 20+ years experience. He's heading Nokia Mobile Network sales configuration and data management topics globally since 2015. He's passionate about people and technology that brings them opportunities, creating data-driven company ecosystem. In the never-ending pursuit of operational quality, automation, and efficiency. Meeting people and new cultures and discovering places near and far. He also studies ancient history and its learnings. Wojciech Maciantowicz. He is a project owner in Mobile Networks Nokia. He has a software developer background with many different areas and solutions. Currently, Wojciech is leading a team of developers who are working on sales configuration project for a Nokia product. One of the features implemented on the tool is an AI-based engine which will speed up and simplify configuration process. Whole solution was designed and developed by his team from scratch. In his private time, Wojciech is passionate about triathlon and ultra runs. Wojciech, the stage is yours.
All right, thank you very much, Remigius, for introducing me. Warm welcome to everyone. Thank you very much for having me here today. Today I'm gonna share with you some of the insights I gained in working, among other things, on product configurators over 15 years working in this space, among other things. So after this, I will share you how to address your product configurability, what are the solutions you may apply, what are the choices you should be making when selling configurable product, why none of these choices is ideal for very complex product that sell with high volumes, and why we think generative AI is the way to go. Now, geez, I haven't had this big PowerPoint in my life. All right, so this, don't mind, where these products are. There is a configuring complexity in the function of volume, and this is a consideration you have to make when making a decision about your product configurability. For instance, a very easily configurable product, like a watch. This can maybe have a couple of straps, couple colors of bezel or casing. This is, maybe you can not make it a configurable product at all. This may be, just a couple models that you break it down to models and you don't configure this product. However, as the number of options grow, and I have seen recently Casio came up with 120 new watch models. Turns out this was one watch, just different colors of bezel, casing, strap. And so this approach has some limits. Now, if you sell windows, this need dimensions. You cannot escape this nature of the thing, so you have to configure the dimensions, at least, materials. Now, there are some products that are extremely complex, but you might not want them being too configurable, like airplanes. With configurability and the number of options comes the challenge of testing all these options, and when safety comes into play, planes like 737, it has a couple of models, like 400, 800. Then the configurability is there, and every plane is different for, in terms of number of rows, how they are spaced, types of the seats. You all from Ryanair, for instance, so you know this difference. But you don't. So when you address such a product, you have to also take these considerations into account. Now, probably one of the most complex configurators available in the retail business, this is for cars. And cars come with many different options, and this sell in volumes. You have to manage this complexity. There are products, and this is a complexity of the thing. Yeah, there are products like professional software. You might think it is not that complex to configure, although I have seen in my life, and this is, when you do it for having in mind how to monetize this business, you might think of different parameters of the configuration. So you don't sell a software as a one piece. You sell licenses for active users. You sell licenses for volume of transactions between the server. All different things. I have seen extremely complex configurators just for a piece of software, and you might want to do it to increase your upsell on the software licenses. You might want to do it to give you a flexibility to price it differently for different customers. So all the big ones in the world do this. You might have different matrices for pricing. So software, by the nature of the thing, might be easy. You might want to make it consciously configurable. Before I move on, I have a question to you. How many of base stations, these things that makes our phones work, how many of those there are in the entire world? Tens of thousands, anyone? No? Hundreds of thousands? Thousands and thousands? Millions? Millions, anyone? Okay. Tens of millions? All right. The good answer is, as with most things in life, depends how you count them, logical, physical, but let's settle on millions, all right? So, and keep that in mind. So, as we move on, some of the most complex, yet still in fairly, solid in numbers, so you need a configurator. The automation of the production lines, all kinds of robotic cranes. These are extremely complex, not so high volumes, again. But what is the question mark there? Anyone guess? Yeah, that's our base station. Yeah, millions of those and hundreds of thousands shipped from single supplier or just a couple suppliers in the world, and extremely configurable. I will talk about it a little bit in a moment. Now, what are the configuration approach that we may have to the product we have? Now, we can, if something is either, very simple, or you are not selling this in high numbers, then you can approach it manually. How it is done in practice? You just have a documentation, sales configuration guides, this type of things. So you hand out to your sales, and they work with customers in very specialized business and of a small scale. In a small scale, this can work as long as you have full control on, what your sales are having at the moment, and as long as it is moderately low complexity. Then, especially when you're a big enterprise or you're selling at a scale, a simple CPQ solution, and CPQ now comes from tens, if not hundreds, of vendors. They serve this simple configuration capabilities very well. They can address also medium configuration. You have a central repository. You know exactly what rules are applied uniformly around the world to configure your product. Now, what to do when you have really a complex product? And most of the time you learn it by heart, because you come to the deployment of the CPQ solution, and after the product gets too complex, the solution is not able to handle it anymore. And then you go into customizations, and this might not be enough. So this is, for this most complex product that you want to configure at scale, you need to customize the CPQ out of the box. And again, there are companies in the world that specialize in that and have, do the external coding on top of the CPQ from major vendors in the world. And you can make it work. I've seen it work for some of this really complex product areas. Not for all, though. And other things fail. And okay, this is not a solution for everyone because this involves a lot of development, and you may just maybe apply it at bigger enterprises. But you might want to build your own configurator, your own software to configure. And for this most complex products, you might want to consider, especially giving doing the business case calculation. This can pay off in mid to long term. So, however, and I will talk again about in a moment how not any one of this is ideal for very complex products. Hence, the ultimate solution would be this AI-based, and we'll talk, and Wojciech, about it, how you can make it happen. Now to our base station. So what makes it so complex? Well, for the starter, you have, as an input, you have your customer requirements. And this ranges from what kind of frequency band it is, which technologies are supported, how many subscribers, active subscribers, what are the traffic profiles, what people use in a certain area, what software features should be turned on in given area. A lot of considerations, how the internet is fed, is it microwave radio, is it optics? So turns out with all this hardware, software, installation options you have on the input side, you have well over 100 parameters, and imagine how hard it is to configure, even with configurator. Sometimes more, more than 150 or even more. And all this input parameters are interdependent. So to make certain number of subscribers, being able to utilize different set of features. So you need the rules, and this is our configuration model. You need the rules, and there are constraints. How many cards, capacity cards you can put into frames, all kinds of considerations that have to be made to eventually come up with the bill of material. And bill of material is a selection of maybe 200-300 different pieces of software, hardware, licenses, services taken from the portfolio of possible 6,000 plus. So the big model that handles all these calculations rules can be several thousands of lines of code to make this working base station, which is by the way, this is not real base station. It's something the AI thinks it's a base station, and so it was generated. So with this big complexity, there are numerous challenges. And these challenges you can very well recognize as data quality challenges. So timeliness. Timeliness refers to the accuracy of the configuration in time. So in the enterprise business, working with telecom operators, but also in many other businesses, it takes sometimes months from the request for information, request for quotation, RFI, RFQ, to the final contract and order takes months, maybe years. And maybe you have heard for how long the Polish railways are working on getting GSMR. So this is like more than 10 years, and it's not happening still. So in time, the configuration loses. What is a proper configuration today is not a one that is in 3 months, because when you have this huge number of components to your product or solution, they progress in the life cycle. Hardware vendors start phasing out, phasing in new parts. Software gets new releases. So what is a correct configuration at the moment stops being correct configuration in 3 months or even sooner. Can be overnight, depending on the life cycle of the product. Accuracy. Now, in the configurators, this depends on 2 things. How good your model that describes all these interdependencies between hardware, software, services, how good it is, but also it depends on how good the input is. And this input at the very beginning is very limited. So again, that's a challenge. Completeness. Now, I'll give you a very, very simple example. So there are these numerous features you want to have on a certain site. And these features you only know once you know exactly where the sites are. Again, so this is, you might not have this information, you might not have some information about the frequencies because, I don't know, the operator doesn't yet know which frequency he has because he haven't, the auction haven't finalized yet. So, and in every business, you might not have all the inputs, so the completeness of your configuration might not be there. And last but not least, the relevance. So when you are just starting your journey with the customer, you don't really need this, nitty-gritty details. How many of these mountings and cables you need the core of the configuration to make rough calculations on your, on your costs, on your possible margins, on your business case. So some of the data you might be getting as an output might not be relevant. And so this is this journey that, in the context of product configurator, you're having with your customer. You start with offering something, and this is very early on. You might be addressing a customer that is a T-Mobile in US, and all your input is you are only maybe bidding for 20% of the United States, and that's it. That's all you know. And only as the negotiation progresses, you might get to know that you will be installing your base stations in Texas, Tennessee, Alabama, and as this progresses, you get to cities of Nashville, Dallas, and certain highways and certain parts of certain states, and then this is where your input is getting more concrete. Now, why this is important? Because there is, when you model this into a piece of software, you model this on a set of input parameters. If you have a generative AI in the background, you might be getting narrower scope, less details at the beginning, and as your number of details that you are giving to the configurator progresses, so progresses the quality of the output. So this is one of the things that makes this better suitable for configuring than traditional approaches. Now, as you progress to contracting, you have to have, again, pretty good details in place, but only after, in the telecom business, you physically get to space, get to see where you're going to install, what is, what are the physical conditions on the ground. You might have all the software requirements, feature requirements in place, but only after you get to the place, you know exactly what are you dealing with, what kind of services are required, what kind of cables, what kind of equipment, what kind of fixtures. And this is, when this, only after that the order may happen. But why delivery is still separate? Oh, well, it might be that, again, this configuration that you are basing off, it's not the right configuration anymore. The time has passed. Some of the hardware has been replaced by a new one, and you don't manufacture the old one anymore. So you have to, again, do this configuration before you end up with delivering the entire solution or a complex product, however you want to name it. That is your final solution. So what I want you to take from this, three things. The configuration, product configuration, there are many ways you may want to address it. There are conscious choices you want to make, whether to make it more or less complex. And if it is complex by the nature of the matter, how to address it correctly, and which solution to take. I believe none of these solutions is ideal in the complex products case, and we believe AI is the way to go. Now handing over to Wojciech, who will be showing us more details about it. Thank you very much. Thank you.
Okay, thank you, Wojciech. Welcome. So AI, it's a very broad topic. So in this presentation, I will just touch the surface of it. But what I want you to take out of it is three things. So the AI is present in our life today and will be more and more in the future in our daily tasks and our daily business. And we don't have to be afraid of it because it's not bad or good from its nature. It's like with the nuclear power, it depends how we use it. And we should use it. We should use it to our daily task, to simplify it and to make our life much easier and these tasks much faster than before the AI era. Okay, but let's start with some theory. I have a question. Did anyone knows what the Chinese room experiment is about? Okay, I see some of you know, so let me refresh this knowledge. So the Chinese room was presented by John Searle in the 1980, and it's assumed that we have two persons, let's call them Laura and John. Laura is Chinese-speaking person, and John doesn't know Chinese at all, and John is locked in a room and communicate with Laura with a piece of paper, and the paper is providing with the small hole. And Laura is providing a message to John, and she thought that John will understand it, but John doesn't understand it at all. But John has a table, so database, where he has some input and the information what should be provided as the output. And he compared the input with the table and write back the response on the same piece of paper and provides Laura back. And Laura thinks that John is well Chinese-speaking person, but it's not true because John doesn't understand it at all. And let's assume that we will replace John with some computer. So the computer will get some information in the input, compare it with the table, with the data that he has, and provide the output which will be relevant to this, what he gets in input. So that's the general overview how the artificial intelligence works. Okay, so let's uh, describe it. Let's dive a little bit deeper. So the AI, the artificial intelligence, is meant to simulate the behavior of human brain. So basically, it should work similar that human brain does. And it's a, let's call it a tuple layer. But we have also something we can call subclasses, which is the machine learning. And machine learning is the bunch of algorithms that are provided to collect the data, and based on this data, provide some predictions and make some decisions. But not only these scripts can also learn by this data and improve the functionality of this his functionality. So as an example, we can provide here the customized playlist or the customized content that we get, for example, with the Google search. And we have also the deep learning. The deep learning works in neural networks. It can work with a big amount of data and can and it's meant to looking for a common pattern in this data or a common feature that are in this data. For example, the image classification. So the face recognition is a very common example of it. And all this ecosystem work together smoothly and provides and helps in our daily duties. Like, for example, the top example, the smart robotics vacuum, like Roomba. Roomba collects the information from the picture that he takes about the room, and then proceed with the path that will clean this room with the most efficient way. Okay, but the subject of this presentation is generative AI. So the generative AI is some kind of additional layer to this whole AI ecosystem. Once the AI was meant to help communicate people with computers in the more human nature, so like the chat, for example, and the things that are that people provide the information and the computer is response. Generative AI is meant to provide some new content based on the information that is already available. So based on the data that the model is trained, and I guess that this way we will use so in the generative pipelines we will use the AI more and more in the future. So because we will expect that the AI will do some work for us, will do something that we will do in the more time, but the generative AI will do this faster. Okay, so let's talk about this data now. So, and the configurators. How can we collect the data for the configurators? So we can start with the simply tagging configuration, and based on this tag, we can provide some description to these configurations, and based on this, we will have information what's in it. We can also gather the information from the settings that the user provides us during the configuration process. But as Wojciech mentioned, it's not always one-to-one, so we can also gather the information from the already deployed product, because they can be different. If so, then we will have additional information. If not, then we can skip it. And when we have this information and when we have the data to train the model, we can push the AI or push the engine to help us in our configuration process. So let's assume that the configurator or the AI engine will help us finish the configuration when we just put some of basic parameters, like, for example, let's take a car. So the user will provide the type of the car, the color, the engine or the gearbox, maybe even the amount of seats, and the AI engine will fill out the rest of the parameters like additional features that can be used in the car, and so on and so on. We can also prepare some configuration that can contain only a few key parameters that will describe this configuration or will describe the final product. Then the user will provide these key parameters, this value, and the AI engine will generate the rest of the configuration based on these key parameters. We can also train the model in that way that the user will only provide some requirements. For example, I want a car. And based on this and some other information that I will talk in a minute, this AI engine will be able to provide the user the full configuration. It, of course, cannot be perfect at each time, but it will be other opportunity to train the model. And what we can do to train the model and to make the model more better and better each time, so we can collect the data from the wider sources. I was mentioned about the configuration and the input that the user was provided, but that can be also the configuration that was already deployed. But not only, we can also comparing these two inputs, and based on this prepare the difference, and the next time the engine can prepare the configuration without this parameter that was changed. And this is the next point, that the engine will prepare and predict what can be changed in this configuration, and based on this generate the configuration that will be more perfect. And last but not least is the NLP. So we can use the natural language processing not only to gather the input, so based on the formula or just with the voice as the user will talk, but we can also gather the information with the processing the other sources like the internet forms or the user manuals or the technical data sheets and so on and so on. And based on this, we can build each time the more accurate response for the user requirements. By the way, I don't know if you know the last time, last week, I guess, one of the common network company was presented the new feature that allows user to configure their network just with the talking, so with the NLP processing. Okay, so let me share some information, some statistics about the AI, which is nowadays. So the AI business will grow because more than 90% of the companies here is already in ongoing process to invest in implement AI in their daily business, and 1/3 of the companies already have it. So it's assumed that in the next 3 years, more than 100 million people will work in AI sectors. But it's not something new because, it's not dangerous for us, because those which use this AI engine now are most of them are content and confirm that these AI engines improve their productivity. Also, the feedback from the other side, from the customer side, is positive, because more than 70% welcome the solution very well. And with the customer services or the chatbots or the customer desk that that was implemented by the companies. But also the same amount of more than 70% are afraid of the AI technology, like the fake news, for example, or to provide not relevant information, and so on and so on. So that's pretty it. As you can see that the AI is presenting in our life, and it will be more and more in the next years. And we can use it in our purpose, in our to work them to our to the things, to do the things that we want, not just creating a fake news, but to creating also the good content. One thing at the end, I'm sure that you noticed that from my presentation there was a robotic pictures in all of them. So you are right, there are better and better one of it. And it was, they all was generated by the same prompt. So it was the robotic with the human face, with the human pose working on laptop. And there was also some negative prompt like not cartoon and some additional like not very sci-fi. So, but for generation, each of them, I was used a different model. So the different model was trained by different bunch of data. And as you can see, for each of models, we get better and better each time. Only for the last one, I was also add C3PO to this prompt, and we get this what we have seen here. Thank you.
All right. So
Thank
now
you
we are looking for some questions, right?
Yes, of course. Thank you very much for the presentation. And now is the time for the Q&A. So if you have any questions, then please raise your hands, and then yeah, you will be able to ask questions. Okay.
Hello.
Well-
I would like to ask a question about verifying whether the AI configuration which is provided to you, do you check it in any way? For example, if you tune some small parameters, then reapply the AI configuration and check whether you don't, I don't know, in case of, no, similarly to Monte Carlo analysis, for example, whether you check if it converges to some good solutions, for example, if you want to maximize profit or minimize costs or something like that.
Thank you very much. I'll take this one. So this is a very good question. I was not addressing this because product configuring is a very broad topic. But thank you for that question. This is when you create a model for your product, you obviously need to test it. And we use automated tests for that. Every time you do the change, you build your test case database, hundreds, thousands of test cases. You run them in the background all the time. You check whether the configuration is correct. So, because basically you run into huge costs if you either provide for that contract the wrong configuration, and so you may lose your margin. Or if you send the wrong configuration to the site, then it's a cost of sending back, delays, customer penalties. So obviously you have to very rigorously test it. In any case, you won't escape from it by bringing the AI. This is the nature of the configuration business. You have to build a good process around testing, automated testing. This is what we used exclusively recently. Is this answering your question? Thank you. More questions?
If you have any question, then please raise your hand. Okay, so thank you very much.
Feel free to catch me later on if you have some questions, so you can address them if you see me later. Thank you very much again.
Okay, so now another important information. So here's the QR code. So please visit the website where you can rate the speakers, and I remind you about the voucher which you can win after the conference. So the next speaker will be Eva Kołotowicz in 20 minutes. So see you in 20 minutes. Please take your seats. We will begin in some seconds. On the front, so please join us here in the front. Tu są jeszcze wolne miejsca. I am pleased to introduce our next speaker, Ewa Kołotowicz. Ewa is a human-oriented in the new technologies world. Communication manager specialized in sparkling presentations, branding and promotion. She believes that people do business with people, not companies. That's why she focuses on relations. Moderator, presenter and mentor. ADHD advocate for neurodiversity, equality and equity. Her mission is to decrease death by PowerPoint syndrome by spreading good presentation practices. Fan of socializing with good food entourage. She has long tried to learn French with average results. Feels much better in the area of communication, which she has delved into with passion for over 10 years, currently in freshly rebranded Nokia. Ewa, the stage is yours.
Thank you. Thank you, Remy. Hello, everyone. Let's start with a short retrospection. Do you sometimes think of the past? Do you like 80s, maybe 90s, or 2000s? I have a feeling that the life was better back at that time. Music was better, movies were better, or maybe life was easier, actually. Are you feeling sentimental about good old times? Yeah, I can see some heads nodding. Well, me too. But who remembers 80s? Please raise your hand. Who remembers 80s? Nice. Yeah, I see a couple of hands. Yeah, all right. I see some liars because they were like 2 years old. I'm sure they don't remember 80s. I assume that most of you remember 90s or 2000s, right? But have you ever wondered, why are we feeling so nostalgic about good old times? In general, nostalgia is a sense of sentimentality for the past, especially for the period of time or places with happy personal associations. I believe that thinking of the past brings back childhood memories with no or just little responsibilities, but for sure with no ASAPs, deadlines, prompts, escalations, and more. I do have a proposition for you for today. This one behind me, it's a DeLorean from 1985, Back to the Future. You know that one? Yeah. We won't be subtracting so many years, but let's subtract 20 of them. And just like this, hello everyone, and welcome in 2003. Now, what's up in 2003? We take on Mars. NASA Mars Exploration Rover mission kicks off with the launch of the Spirit rover. What else? Google launches AdSense to feed us with more targeted ads. Also, Apple opens iTunes Music Store and launches a third generation of iPods with this funny round little thing called the touch wheel. What else? MySpace starts, and it becomes the first major social media platform. And as a curiosity, the Facebook is going to be opened an upcoming year on February 2004. Let's turn on the radio. What do we hear? Feel where we are. What's up in sport? Well, this guy, Michael Jordan, plays his last match for an NBA. So the last dance for Air Jordan. And the same year, LeBron James is drafted with a #1 for his hometown team, the Cleveland Cavaliers. I believe he led them to the championships on 2016. I hope I haven't mistaken this one because my husband is a huge fan of NBA and he is somewhere over there. Okay, Roger Federer wins his first Grand Slam. And today, he's got like 20 of them. And you see this young fellow? It's Lionel Messi, aged 16 years old. And in 2003, he's got his team debut for FC Barcelona. And for those who deny, today he plays in Inter Miami. Let's go to the cinema. What are we watching? Finding Nemo. Who's got kids? This one is like Shrek. It's ever timely. But we also have the Pirates of the Caribbean, with an amazing creation of Captain Jack Sparrow, played by Johnny Depp. Lord of the Rings, that's part number 3, Return of the King. Okay, so did you catch that 2003 spirit? Yeah? Great, you feel where we are? So it's 2003, more precisely 16th of January 2003. We are at the Kennedy Space Center on Merritt Island, Florida. The weather is sunny, a bit cold, and quite windy, actually. And the Kennedy Space Center is one of the 10th field NASA's center. And since 1968, it's a primary launch for the human spacecraft. It's 10:39. Everyone feels something big is happening. In front of our eyes, the Columbia Space Shuttle launches with its crew of 7 to the low orbit. Columbia has been the first shuttle, firstly launched in 1981, and it's been on 27 missions prior to this one. While the other crew shuttles were working on the Hubble Space Telescope or International Space Station, this mission was one of the pure scientific research. Their objective was to study the effects of microgravity on human bodies and also on ants and spiders they took with them. So the launch proceeds as normal. The crew settled into their mission, and now they're going to spend 16 days in an orbit completing 80 experiments. At 82 seconds into the launch, as the shuttle rose with 29,000 kilometers per hour, a piece of insulating foam, so-called SOFI, fell off from the main fuel tank and damaged the left wing. More precisely, it has collided with one of the tiles of the other edge of the left wing. As a matter of the protocol, NASA reviewed the footage from the external camera mounted there. And now, what's SOFI? SOFI is an insulating foam. Not surprisingly, it's used to insulate the tank, so ice cannot form when it's full of liquid hydrogen. And if ice were about to form, it could break off and damage the shuttle during liftoff. So NASA reviewed the footage from the camera, and just to let you know, SOFI, the foam falling down during start, was nothing new. It happened on 4 missions before this one, and it was one of the reasons why camera was put there in the first place, right? But the tile that the foam had struck was designed to protect the shuttle against heat from Earth's atmosphere during launch and re-entry. So, in space, the shuttle was safe, but nobody could say how much damage caused this foam falling down 9 times faster than a fired bullet. There were several options. The most reasonable seemed to be the ones that you already see. So NASA could launch another space shuttle to pick the crew up, so basically to evacuate them. But I believe this one is also the one which is the most expensive. Or the astronauts could perform a real spacewalk for the visual investigation of the hull. Or the NASA could risk the re-entry of the shuttle. So NASA officials sat down with Boeing engineers who took them through 3 reports, a total of 28 slides. The salient point was that there was data showing that the tile could tolerate being hit by the foam, but this was based on the condition with the foam 600 times smaller than the one that had struck Columbia. So, would Columbia survive re-entry into Earth's atmosphere, or would the wing damage cause the spacecraft to be torn apart? In a second, I'm going to show you the slide that the engineers chose to illustrate their point. With the first eyesight, you see that it's quite heavy, right? It's a bit overloaded. We're going to analyze it later. So the NASA officials listened to the Boeing engineers and their PowerPoints. And they felt that the engineers weren't sure what is going to happen, but the data pointed there didn't prove that the life of the crew was in danger. Okay? So they have rejected the other options and pushed ahead with a Columbia re-entering the Earth atmosphere as normal. So Columbia was scheduled to land on February 1st, 2003. Now, from my observation, this is a very common issue that we experience today in IT. We have a lot of professionals. We've got the engineers, we've got developers whose expertise is really high, who know a lot. But if it comes to present the data, if it comes to convey the message, especially through PowerPoint, then it's like, Houston, we've got a problem. Usually these slides make nonsense for non-technical audience. And I believe this is what happened with this one as well. At 60,000 meters above Dallas, with an 18 times the speed of sound, the temperature readings on the left side of the shuttle were abnormally high, and then they were lost. The tires pressure on the left side were soon lost, as was the communication with the crew. At 9:12, as Columbia should have been approaching the runway, the ground control heard reports from the residents near Dallas that the shuttle had been seen disintegrating. Columbia was lost, and with it, her crew of 7. The shuttle program was in lockdown, grounded for 2 years as the investigation began. The cause of the accident became clear. The hole in the tile made by the foam let the wing dangerously overheat until the shuttle disintegrated. But there was still one question with no answer. Why, given that the foam strike had occurred with the forces massively out of test conditions, had NASA proceeded with the re-entry? Edward Tufte, a professor at Yale University and an expert in communication, reviewed the slideshow that the engineers had given to NASA. And his findings were very profound. So let's analyze them together. That's the slide that you already know. You've seen it before. Let's have a closer look. With the first eyesight, you see it's quite heavy. It's very overloaded. There's more than 100 figures or words in the one screen. But first, what we see is a header. And this is obvious because this part is the biggest part of the slide and it's written with the biggest font. So in theory, there should be the most important message. And this slide has misleadingly reassuring information that the tile could withstand the foam strike. And it's just here. That was not the case. But the presence of that on the very top with the biggest font size makes this seem to be the salient summary point of the slide. And this helped engineer's message to be lost almost immediately. Secondly, there's 4 different bullet points with no explanation of what do they mean. Is the bullet point number 1 the main bullet point? Do the bullet points become less or more important? With all the indents and bullet points, there has been 6 levels of importance created. So 6 levels of hierarchy, and actually the audience, which means NASA officials, could make their own hierarchy in their own heads, because there is such a huge space for the interpretation for the audience. It doesn't help that there is also some indents written with the smaller font size. So there is a font size as well. Word Sophie and ramp means exactly the same. It's the foam. So VAX terms are being used. Sufficient is used once. Significant or significantly 5 times with little or no quantifiable data. So again, this leaves a lot of interpretation to the reader. So how significant is that? Is it a statistical significance, you mean, or something else? Then, finally, the most important message of the slide is at the very bottom. Absolutely lost. The information that says that the tile could withstand being struck, but this happened at the forces massively out of test data, it's at the very, very bottom. 12 little words that you have over 100 to wade through if you even keep on reading until this point. So subsequent report criticized technical aspects along with the human factors. Especially they pointed out over-reliance on the PowerPoint. The board views the endemic use of PowerPoint briefing slides instead of technical papers as an illustration. How about if the engineers had put up with the slide like this one? The foam strike more than 600 times bigger than test data. Maybe NASA would have listened. Maybe they wouldn't attempted the re-entry. We don't know. But today, while giving this speech, we're thinking of the Columbia crew and their families. And at the same time, we must be aware that PowerPoint may kill, sometimes literally. So now, as you think it went the worst, and it can't get any worse than that, let's vote for the worst slide ever. So please take your hand, scan the QR code, and I will go through these monsters, and we will together find out which one of the monsters is the most scary one. Is that number 1? Ooh, pretty ugly. Don't try to delve into these arrows. They have no sense. And it's actually the one that is being used for the military. Okay, number 2. Ooh. I think that this one got stuck in like 80s or 90s, right? Pretty old one. Or maybe number 3. Oh, you're familiar with this one already, aren't you? Or the number 4. Yes, this one is an eye-torturing one. And the winner is? Number 4. Yeah, congratulations, or not. So that's the worst slide ever. It's been chosen by you. And I can assure you that if you present the slide like this one, 90% of what you said will be gone within 90 seconds. Well, maybe for some of you, 90% is not that much, because if I've seen the slide like this, I'd rather forget 100% of what I've seen. But as you perform, as you speak to the people, as you present, would you rather be remembered and listened or forgotten? Well, that's the rhetorical question, right? We've got 300 million PowerPoint users. They generate 30 million presentations each day. At this moment, while I'm giving you that speech, over 1 million presentations are being created. And guess what? 50% of them are unbearable, which means that 15 million PowerPoints per day are very, very bad. As you can see, the problem is huge. The issue is really common. So I prepared something special for you for today. And I'd like to give you 5 rules of presenting data in PowerPoint. And my objective is to give you 5 principles that will cognitively and psychologically optimize your PowerPoint slides while presenting data. And I can assure you that if you haven't used them before, they will make the tremendous difference to every of your presentation that you'll be delivering from now on. Ready for it? Rule number 1. 1 idea per slide. Why is it so important to have only 1 idea per slide? Let me tell you a story. You're at a house party, talking with your friend, sipping a beer, and your friend is telling you this amazing news about solid programming languages. So you talk together, oh, that's very interesting, yeah. And then suddenly, this girl is walking through the doors. And she's wearing a red dress, an absolute attention grabber. Moreover, you can hear her saying your name. Are you still listening to your friend and the advantages of solid programming languages? Nope. I love this one. Your attention is now diverted into your friend, and you know the way, hoping you're nodding at the right moment, and to that girl in the red dress. And the worst is yet to come, because the girl leaves the room, so your attention is going back to your friend, and you face this question, well, don't you agree with me? So this is what happens when you have more than 1 idea per slide. Our brain is just not made to analyze 2 ideas per slide. You'd rather focus on this one or on that one, a little bit on this one, a little bit on that one, and you will take nothing from this slide because it leads to the cognitive overload. And I believe that you have this brilliant idea in your head and you'd like to share it on the slide. And you need to elaborate. And I'm absolutely fine with that. But if you need to elaborate, just skip to another slide. Rule number 2, size matters. I borrowed this slide from my friend developer Adam Badura, who's actually a speaker today as well. But this is a slide from 2016, and he much improved since then. But it's not that bad. Anyway, where is your attention going to? It's a bit like everywhere, right? But I'm gonna tell you why the size really matters. Because every PowerPoint template is made like this, that the headline is the biggest object followed with the smaller part of the body, right? So my question is, why are we so rebellious towards PowerPoint? Why are we always rebellious towards PowerPoint? Because how many times the headline is the most important part of the slide, and why almost never? Okay? Even though we have this hint with all that templates. But okay, if you really like to act in opposite to your biological reactions, then you have to play with the size. And like here, we don't play with the size. But then, let's have a quick look of another example. Where are your eyes going to? They suck down with the headline. And that's obvious because it's the biggest part. And whatever you'd like to do, wherever you'd like your eyes to be going, they will constantly come back to the headline. How about now? Your eyes are falling down to the content, right? Eyes suck with the headline, eyes falling down with the content. You have a power to control your audience's attention. So use the PowerPoint the way it's supposed to be used. Rule number 3, 6 lines. So why 6 lines is an optimum for each slide? If you follow the rules that the headline is the biggest part, let's say with 40 points, and the subtitle is around 30, then the body is at a minimum of 16 points. Why 16 points? Because it's the smaller size of the font to be visible for the audience. And if it's at 16 points, you will just not be able to place more than 6 lines per slide. So how many lines? It's an optimum for the slide. 6 lines. How many? That's right, thank you. Rule number 4, give them a value. And to give them the value, you have to know what's them and what value is. Now, them stands for the audience. You have to know people that you're talking to. And knowing the people helps you to find out the content and the message that will resonate with the people, that will affect them, right? You do the profile to choose correct vocabulary, language, the level of expertise, and all of that. It's an advantage to you as a speaker to know your audience, right? Because you find out what's valuable for them. Valuable, that's right. How about the value? The value of your presentation is not what you'd like to say to your audience. The value of your presentation is not this brilliant idea or this wonderful data you found out and you'd like to share. It's not the message you'd like to convey through your presentation. I would say it twice because it's quite important. The value of your presentation is the solution you can provide to your audience to solve their problems. The value of your presentation is the solution you can provide to your audience to fix their problems. Now, your audience spends, I think, the most valuable resource nowadays, which is their time, but they expect something in exchange, right? That's why the speaker should never think through his own prisms unless regarding to what but what I can offer to my audience. What data might be interesting to them and why? Why presenting this data is beneficial for them. That's the trick. And we have rule number 5, and it's going to be a contrast. And regarding contrast, I wouldn't like to tell you about your graphic slide designs. But at the same time, I don't want to commit the curse of knowledge, thinking that you know something that you don't know. So I'll just tell it once, that there is nothing more annoying than white colored background followed with white or light font, and then opposite, the dark colored background with dark fonts. I'll just quickly show you how it could look. Oh. Again, eye torturing, right? But regarding contrast, I'd like to tell you that contrast helps to control the focus of your attention, right? So once again, if we have a slide like this, your attention is like a bit everywhere, right? How about that now? Where is your attention going? To the point that I've emphasized. The rest is hidden. And then we move swiftly to another one, and we hide the first one. And then this way, your eyes are going exactly where I would like them to go. And now you're going to ask me if it works with the tables. Yes, it does. If you have a table like this one, right? You can emphasize your data by using a bold. Is that the best you can do? Not really. How about that? Now it's much more visible, and everyone know what are you talking about. At what part of the slide are we? Okay? So once you remember these 5 rules, 1 idea per slide, size matters, 6 lines, the value, and the contrast, you will find out that this is just a toolkit. It's an ad. So why is it so important? It is so important because it's not the PowerPoint who makes the presentation. The presentation is you. You who present, you are your presentation. And this is just a background helper to emphasize your ideas. So as a summary, I'd like to tell you that the PowerPoint may kill, sometimes literally. Don't eclipse your great ideas by the death of PowerPoint syndrome. And don't torture people with your slides. Let's present the data that truly matters. And let's, together, decrease the number of a death of PowerPoint. Thank you for your attention.
Much, Eva. So now is the time
Thank
for
you.
questions. So if you have any questions, then please raise your hands and then. Okay.
Hello? Oh, okay. Eva, thank you. First of all, thank you so much for the great, fantastic presentation.
Thank you.
And I have a question. Which of 5 principles is most important for you? Because for me, I have already admitted, but for you, which of 5 principles is most important?
Okay, thank you for that question. Very good one. Which one is for you? all of them. Yeah, all of them are very important, but I believe that the most important one is the value. Is the value, so I will just once again repeat that the value of your presentation is a solution that you can provide to your audience to solve their problems. So if the people see the value in your presentation, they will be listening to you, and your presentation will resonate to them, yeah? So I think that the most important is the value. But don't forget to use all of them, because if you have a value and then you have 4 ideas per slide, you know what's going to happen, right? Thank you.
Hello, hello.
Hello.
I think that nowadays we are forgetting that when we deliver presentation, we are doing presentation, or rather we are not showing presentation. We must remember that we are presenting, and the presentation is the background. It's something that helps us to convey the message. And well, the best presentation is the one that you don't really need to build and spend many hours before the actual event happens. Because remember, you need to show the data, you need to gather it anyway. You need to base on facts, not on some feelings. So I kind of agree with all 5 points of that. But please remember, you are presenting, you're not showing presentation.
Definitely. Thank you for that point. I could talk with you later on as well. Which one are the ones that you'd like to talk about? Well, I think that all of them are important, but what you said is a bit of my summary as well, where we need to collect the data, we need to analyze them, and what we're presenting is just the top of what we've been doing. And to be honest with you, I think that to make a good presentation, you need to spend quite time on it. It's not like you don't have to spend time, because even collecting data, even analyzing it, that takes time. And what you're showing here is just, the summary of your work, right? So thank you. That's a very nice point as well.
Okay, and what about tooling? I think we are still focusing on Microsoft PowerPoint. What about other tools? Are you using them in your everyday work, or you are just focused and you best known the Microsoft tool and choosing it like automatically? Did you try to compare them? Do you have any options about other like slides or any other application that maybe is better? Because I would a little bit disagree also with my speaker. This is beauty, right? This is like this a little bit of cookie that you shown us. This presentation is beautiful. It's eye-catching also. So how to, or what tool are you using to prepare such a beautiful things?
Well, this is all made by the wonderful graphic designer who's actually here, Marta, thank you, who's actually the professionalist who does it. And she does it in PowerPoint, but she uses AI for the graphics. So you saw me, I'm not an astronaut. I haven't been to space, but you may assume that I was wearing these suits. So it's all PowerPoint, and I stick to PowerPoint, basically, at work. For some reason, I also like Prezi, but I know that Prezi has a lot of haters. But I think it's interesting, actually. Prezi is also interesting, and I used to use it at my previous work. But also, this is a main tool that we use at my work for the organization I'm working at the moment. So the same as yours, I believe. Yeah, and I think it gives us such a huge possibilities to make a strong and a very good regarding graphic design presentation, that is much more than enough. Cheers. Thank you.
Hi, Eva. Thank you for your presentation. And I mean, these shoes are amazing.
Thank you.
So here is my thought. What about choosing the right tool? Because in my opinion, the PowerPoint wasn't the best option for this kind of message about the Colombia issue. So what are your thoughts on that?
What would you choose? What would you rather see than PowerPoint?
Something, I don't know, a text document? To be honest.
All right. Okay.
Because I think it's easier to pass that kind of message that is really, really important, and it needs to look like professional and so on. So, well, I probably will use a Microsoft Word for that.
Okay, thank you for that opinion. Yeah, you have to know that the presentation is made like by 3 different parts. The Colombia part is just one of the parts. The first one was back to the past actually, and the third one is like the principles that I gave you. So that's why I've chosen this tool, because it combined on three different issues. So 3 different stories that I wanted to show you, and that's why I used the PowerPoint. It's also the rules that we have in the house. So for the code dive, we'd rather present through PowerPoint or PDF. So also that was making my choice as well. Thank you. Great question. Okay.
Okay, then thank you very much once
Thank
again.
you. Thank you for your attention. It was really nice. Thank you.
So now after the Q&A section, now you can rate the presentation with the QR code visible on the screen. And now we will have a 30 minutes break, more or less. And after the break, the next presentation starts at 11. And if you are feeling hungry, then you can purchase pan pretzel and coffee on the ground floor and second floor. Additionally, I would like to remind you about our available attractions, which I mentioned in the beginning of the conference. So see you at Marta Handler's lecture at 11.
This with Duolingo. Thanks God. I actually thought I was going to be the only person in the room who's on a free trial. So I could also ask a third question and ask you about any AI-enhanced app. And then I would probably see the hands of the majority of you. That is because we stepped into a phase when artificial intelligence is basically everywhere. And it seems that also everyone is an expert in it. And that is why I'm especially happy to see this many of you today, because I'm here to hopefully show you something new regarding machine learning. Namely, I'm here to present an idea that my team and I developed into a working solution. And just a small disclaimer here, I do not own the idea, but I had this great opportunity of heavily contributing to the whole project. So let us begin with a very short recap of how a typical machine learning project is usually conducted. You may come across a different set of phases here, but ultimately they are all pretty similar. We start with a problem that we need to thoroughly understand. A problem that we also think it might be beneficial to use to solve using some machine learning techniques. So we define it, and we plan some appropriate experiments. Once we've done that, we can start collecting our data. In this case, the more, the better, or at least to some reasonable extent. So once we have it, we begin to process it, and this is probably the most tedious part of the whole project. Data wrangling can actually eat up a lot of time, since we often have to deal with extracting features of interest, among many, many others present. We also often have to deal with the missing data. Sometimes we need to label the data. So it's definitely much more than simply dropping non-applicable entries like you would commonly find in some online tutorials. But if we manage to do this, we can proceed to probably the most exciting part of the whole project, which is model development. In this phase, we decide to use some kind of machine learning algorithm. We also choose our metrics to further evaluate our model with. We can then feed our model with the data that we collected, and we can also fine-tune it. Then we get some results, and hopefully we are satisfied with them. And the last phase is about utilizing the project and the whole model. And I marked this phase with a slightly different color on purpose. It is because not all projects end up with a deployment-ready solution. Some projects are strictly for research purposes, and others are simply not good enough. So there can be a lot of different things here. But the reason I'm going through this chart right now is because I would like to now lead you through our project, phase by phase, as it is defined here. We will therefore begin with the problem statement. So the problem we wanted to tackle was the assessment of the performance in mobile networks. These networks are changing incredibly fast. A typical mobile network is defined by thousands of parameters for each object within the network. And the state of such network is also additionally affected by some external factors, like, for example, the weather conditions, or temporary fluctuations in the location or number of users connected to this one network. So what we want to know is whether introducing some kind of change to the configuration of this network will result in any kind of change in the overall performance. So at the lowest level of complexity, our problem can be defined this way. We have a single network object, like a single cell. And we know that at a given moment of time, there was some configuration change, the moment that is here marked with a dashed line. So we have configuration 1 for the period before the change, and similarly, we have configuration 2 for the period after the change. And now, how to tell whether any change in the overall performance occurred? And if it did, how to assess whether it was positive or negative? Well, there are some simple methods to do this. Usually, a comparison before-after is used. So you take, for example, the average value of the KPI from the period before and the period after, and you compare them to actually say whether you note a gain in the performance, so an increase in the performance, or if you note loss, which is a decrease in the performance. And what is also more important is the term KPI. So I know that it is probably a very common term for the majority of you here, but it can also refer to all sorts of things, all sorts of measures. So in this case, I would like you to think of a KPI as of any type of signal that tells us what the current performance in the network is. Okay, but we have some solution, some simple method, right? But as you may imagine, this problem must be far too complex to simply compare the averages. And that is correct. And here's a good example. So on this plot, you can see the KPI values for a single cell in the network throughout more than 10 days of constant measurements. And although the title of the plot clearly tells you that no configuration change happened, you can see that we can actually quite arbitrarily choose some moment of division of this period and create these artificial before and after periods. And what we see here is that the average value of this KPI for these two periods is actually very much different. In this case, we have a decrease by more than 18%, and that is a lot. But why is that? Why does that happen? Well, because like I said, mobile networks conditions are often unstable. So in theory, we expect this KPI to be periodic, but there are many exceptions to this rule. What is more, such a KPI depends on dozens of other indicators. So the conclusion would be simple here. We just need a more sophisticated method. So what my team did is we kind of shifted the way of perceiving this problem. And instead of a typical approach, which is what is the current performance compared to the previous performance, we asked ourselves a slightly different question, which is what is the current performance compared to the expected performance? And by expected performance, I mean the performance that we would most likely observe in the network if the configuration change didn't really occur. So translating it visually, it would look like this. Instead of comparing the values of the KPI and the before and after period, what we want to do is we want to compare the actual measured values of the KPI and the period after to the KPI values that we would most likely observe if configuration didn't change. And we can achieve it by making some predictions for such a scenario. And I'm saying the keyword here, predictions, because this is exactly the moment where we will utilize a machine learning model. So on the left-hand side, the gain, so the increase in the performance, is given by the difference between the average value of the KPI from period before and from period after. However, on the right-hand side, the information about the gain will come from the difference between the predicted values of the KPI and actual measured values of this KPI. And this difference between the true values and the predictions is nothing else than just the error produced by the model. So now that we have understanding of the problem, and we also have an idea on how to solve it, a phase 2 of the project should come, which is data collection. But on this process, I will not elaborate very much, because we simply have not that much time. It is just sufficient to say, though, that we actually had tremendous amounts of data, and we actually spent a great deal of time extracting the proper features and proper input for our models, and on processing it for further modeling. And what I want to do now is to proceed straight to the experiment design. So we designed our experiment in this way. Knowing the moment of configuration change, which is once again marked with the dashed line, we took some part of the input data for the period before, and we used it for training. In this way, our model only learned the dependencies that held true for the configuration before the change. Then we used our trained model to make some predictions for the remaining part of the period before and for all the data from period after. Now, we took the model error for each measurement point from both of these periods, and we calculated the median error. So to calculate gain or loss, respectively, what we do is we subtract one median error from the other, and we divide it by the average value of the KPI in the period before the change, just to ensure that we get the result expressed as a percentage. And that's it. That's the whole idea. But I know it may seem complicated at first. Someone could even ask if we can actually believe that the model error will give us trustworthy information about the gain. Because after all, it's an error, right? Something that we don't want to have, or something that we want to have minimized. But let's consider together a simple example. Imagine that you participate in a survey, and you're supposed to give your estimates on how much would it take for you to complete some simple activities, like cooking dinner, doing laundry, paying bills, etc. Let's say that you provided your answers, and now you are supposed to actually perform those activities. And imagine that someone is going to measure the time that you actually need to complete them by talking to you on the phone and then checking the time of your call. A weird way of doing this, but the measurement would be valid, right? So the results of such survey might look like this. So what we observe here is actually a common fact. The fact that when we need to multitask or when we need to split our attention, we tend to perform worse. So in each case here, you underestimated the time that you needed, but only by some near constant value. So now for the sake of visualization, I will draw a line between those points. And I hope it starts looking familiar to you already. So if I were to inspect such a survey, I would say that you are totally credible. It's not like you said you needed 30 seconds to tie your shoes and then it took you 30 minutes, right? What I can see from this results is actually you are totally capable of predicting the time that you needed. You just didn't know that there were going to be some external factors, like a phone call, that were going to distract you. And this is something that we assume when working with our models. But to be able to make such assumptions, we need to be sure, and we need to verify actually, if we can really successfully model this particular KPI. And this is something that we did in our preliminary checks. So at first, we created a single model for each object and each configuration that were present in our data set. We checked the metrics, and this time we really wanted to minimize our model error. And we validated overall good model's performance. So we took the second step. And this time, we created a single model for all objects sharing the same configuration. and we of course repeated it for every configuration that we had. And this time, the ability of the model to accurately predict the values of the KPI was even better than for the single object models. So we took the third and final step, and we created a single model, this time much more complex, for all our objects and all our configurations from the dataset. And this time, the model performance was also more than satisfactory. Okay, so now I hope I managed to convince you that we can actually trust the error, that we can model this particular KPI, and that our experiments were well designed and our methodology was correct. So what about some results? Here's one example. So here we have two configurations, 3229 and 46795. We also have a moment of the configuration change, this time marked with red. We have the true KPI values, so the measured values, in black, along with the predictions, which are in blue. And we have just seen something very similar, haven't we? So the crucial information here, something that we know because we have our telco knowledge, is that for this particular change in the configuration, we can actually expect a decrease in the performance. And this is exactly what we observe here. Look at how the predictions in the after period are always slightly above the ground truth. So after the calculus, the change, so our loss in this case, would actually be around 16%. What is more, look how in the before period, the quality of the prediction is actually really good, like really high, because here, the model error is really minimal. And this is probably the perfect way of me showing you how our method works in practice. But now, let's just put those plots aside for a while. Do you know the differences and the similarities between a parrot and a machine learning algorithm? So just in case you don't know the meme, I have a very short summary for you here. And I admit, I did want to make you laugh with this one. But I have a valid point to make as well. Namely, I'd like to focus on this trait here. We know that models actually don't speak nonsense. A model can only respond to poor data. But it kind of refers to what I want to underline here, which is the fact that our solution has its limitations too. So first of all, the fact that our solution really works does not mean that we always get the perfect results. And except for trustworthy, valuable gain results, our method also sometimes produces nonsense. So to be as well prepared for that as really possible, we use some statistical tests to differentiate between statistically significant and insignificant gain results. But even these tests do not handle our uncertainty in 100% of the cases. And that is heavily connected to the second great difficulty, which is the lack of absolute reference. And by absolute reference, I mean some other assessments result that we know of that are objectively correct. So we can, and we of course do, compare the results from our method to some other methods, like for example, the simple before-after comparison that I showed you before. But even those results are not to be trusted at all times. So because of all this uncertainty, we need to sometimes manually inspect our results and validate that they're actually correct. And to do so, we need to rely on some expert-level domain knowledge. And this, as you may imagine, makes the process of interpreting those results and drawing any valuable conclusions much longer. So I felt that this was the only decent and honest thing to do, to show you that our solution has also downsides, but so does any other. Because I dare say that for such complex problem and for such difficult and complex data that we have here, no solution can be ever perfect or totally universal. What is important, though, is that our method of assessing change in the performance by the model error works really fine, though. And what is also true is that there are some difficulties here, but it doesn't change the fact that our method is so good that it just stepped into the deployment phase, which is, as you may recall, the fourth and the last phase from our typical machine learning project lifecycle that I showed you at the beginning of my talk. And this is something. So to wrap this up together, I've showed you our idea. I've showed you that it works. And I've showed you that there are obviously some limitations to it. But what's in it for you, really? Well, I hope that after all, you were able to see something new, something fresh in machine learning. So my message here is not copy-pasted. Go use model error as a source of information in all of your projects now. No. What I would really like you to remember from my talk is that there really still is a place for something new, for some kind of novelty and innovation in machine learning. So as you have just seen, model error can be, in fact, turned into our asset. It's not something that we always have to just avoid or try to minimize. And what is more, if you plan your experiments correctly and then validate the correctness of your approach at each and every step of your way, then you actually don't have to stick to rigidly defined principles. You can actually make them work for you. And the last thing, probably most important, I hope I was able to somewhat inspire you and to prove with my presentation that you can achieve great results, great outcomes by thinking outside of the box. Thank you.
Thank you very much, Martha, for a really interesting presentation. So now it's time for Q&A. So if you have any questions, then please raise your hands.
Hello, and thank you very much for a nice presentation. I have a question on this prediction of the next availability of the KPI when we are talking about. Sorry. My question is that we can have two approaches. One is that we consider it as a prediction on its own. I mean, we have past values, then we predict the next value based on same KPI. Or the other approach is to, for example, find KPI 2, 3, or 4, which are related, which are correlated with this KPI, and calculate the next value based on those KPIs. So my question is that because both of approach have their downside and they have some advantages and disadvantages. So which approach did you take, and what are the benefits over the other approach? Because if I may add this explanation, that when some kind of changes happens, this is not just one KPI, like configuration change. not just one KPI that goes down or up. There are many other KPIs which are related and they are going ups and downs. So, for example, if you choose the second method, considering other KPIs, then you should consider also that those KPIs will be affected because of that configuration change.
Yes, so thank you for the question. Well, a short answer, we use second option. So, but the longer answer would be that, well, we actually didn't really consider the first approach because that would, if I understand correctly, that would actually mean experiment based on some time series forecasting. And this is not the approach that we used. So we actually prepared the input. The input that was, that varied throughout our experiments, but it was consisted of some other KPIs, and that was it. So we did not actually pay attention this much to the time series of the KPI, just to the inputs, because actually this was the only reasonable way, when I think of it, to actually satisfy our requirements for the experiment, because we only wanted to take into account, when training the model, we actually wanted to only take into account the configuration before, so as to make sure that our model does not know the configuration after. So I guess that the first approach wouldn't really be applicable here even. So I hope that's okay.
Thank you.
Thank you. Any more questions? You see, like I told you, everyone is already an expert.
So hello, thank you for your presentation. I have one question about the methods. What kind of machine learning methods do you use for making prediction? As far as I remember, it is kind of regression utilized on time series. So maybe a few words about that.
Yes, but can I actually ask you something in return? Do you mean like the algorithms, like the choice of algorithm?
Yes.
Yes, so, well, it also, yes, it was a regression problem, so that's correct. And as far as the algorithm goes, it was also, it was changing, because I showed you the 3 stages of, building some models. So for the smallest models, these that had only information about a single object and single configuration, then we also had limited and quite small data there, because there was only obviously one object. So in this case, usually, well, the simpler, the better. So we often used simple linear regression. We also used some variations on it, like, for example, a ridge regressor. We also tested XGBoost, because it is proven that it works well with small data sets. But actually, as our experiments proceeded and as our models grew bigger, we actually could not use such simple models anymore. And finally, for this more the most complex model, we actually just used a neural network. So a deep learning approach.
How long does it take to train such a model? So you gather the data and you pass the data to the model, create a model, right? How long does it take?
So I'll just repeat in case not everybody heard. So the question is about the time that we needed to train our models. So once again, we created different models of different level of complexity. So those single models, for example, the ones that we used the linear regression for, they are actually like near instantaneous. So it's really, really fast. And as far as the more complex go, they actually required much more time, but we are talking about hours and not days. So it wasn't like that much time. Thank you. Yes. Okay, well, that is actually a very important question. Well, everything that you said is really true. That's correct. So let me just quickly elaborate. So those three experiments that I showed you, they were mostly well, they were mostly for validating that we have good prediction capability. So we didn't care that much about calculating gain in this stage. We only wanted to verify that we can use actually those models, this approach, to calculate our gain, but later. So that was this preliminary check, and we only cared for the performance. And as I said, we only wanted, good performance. So we wanted to keep our model error at minimum, and so on. But in fact, later, as we proceeded to calculating gains, and we also did this for several models, we were also adjusting the amount of information that we treated as an input. So we were limiting the input, and we were, for example, cutting out those after configurations. So actually, our model did not have the knowledge or the input that considered those configurations after. So as not to, just like you said, so as not to disturb the idea behind the modeling. Yes, exactly. Thank you.
Are there any other questions? If so, please raise your hand.
Hello.
Hi.
How do you pick these first parameters to start research?
It's all mostly related to this telecommunications knowledge. So we have, like I said, there are dozens of other indicators, and they so the primary choice comes from the knowledge. Let's say that we know that some indicators are in relationship with the KPI that we actually wanted to model. So that was an obvious choice. And then there's this process of verification if those are actually the proper inputs. So there's like a whole procedure of checking it if we shouldn't like append some other indicators to the list, and from that point it's kind of an iterative process. But it's mostly related to just the knowledge about the characteristics of the data.
Okay, thank you.
Thank you.
Okay, I see no questions, so thank you very much for a really nice discussion. Thank you once again, Marta.
Yeah, and if I just may say one last thing, those were actually, all those questions were totally brilliant, and I'm happy that I got them, so shout out to you. Thank you.
So please keep in mind that there's a QR code where you can rate our speakers. The next speaker will present at 12, so in 25 minutes. So see you in 25 minutes. that we have almost full seats, so maybe we can start. So please join me in welcoming our next speaker, Borislav Stanimorov. Borislav has been writing C++ software for more than 20 years. The majority of his career has been in video games, and in past 4 years he's been working on software for medical devices. He has worked on C++ development software for all kinds of platforms: desktops, mobile devices, servers, and embedded. His main interests are software architecture and design, and programming languages. He also writes the occasional tech blog posts at ibob.bg/blog. So if you are interested, then you can go to this website and look on his blog. Borislav, the stage is yours.
Thank you. Right, this talk, right? Can you hear me? Okay. So we have 2 hours. Hopefully that's enough. I'm Borislav. As you've seen, if you want to follow the slides on your phones or laptops or whatever, you can find them on is.gd/AICP-intro. As introduced, I mostly write C++ professionally since 2002. Yeah, that's a lot of years. And what's been missing from the introduction is that, I recently started doing machine learning. So I kind of skipped the IoT hype. I didn't become a blockchain engineer. I didn't even become a infectious disease expert, but this time I'm riding the hype wave. This talk, you should keep in mind that it's more inspirational. So don't expect to know much more after this talk, but hopefully you will want to know much more. It has a lot of personal opinion about software, so it's not for the faint-hearted, I guess. And it's more technical than philosophical, so I wouldn't be delving into topics of how AI will kill us, the 3 laws of robotics, and how Bill Gates wants to insert chips in our bloodstream with the COVID vaccines. Also, this is a bird's eye view. So as you might know or might suspect, the topic is huge, worthy of more than 1 course. So a single talk is hardly enough to give it the time it deserves, I guess. The target audience here is mainly programmers who are not in the ML field. So the ones who are will probably not learn anything or not see anything new, except my personal opinion, which is always valuable. And who have experience or at least interest in writing low-level stuff. So stuff that's typically written in C, C++, and other languages like that. Yes, Rust also, yes. I will try to basically cover why you should consider doing stuff like machine learning and how your existing experience can be transferred there. So a bit of background. Unless you've been living under a rock for the past, I guess, year and change, you have certainly seen and probably used these things, most of them, some of them, if not all of them, I guess. And currently with the explosion of popularity of AI, we've also seen an explosion of sorts of AI tools, startups, software as a whole. And practically, there's something new AI every day, or not even one thing. There are many things AI new every day, and then this talk will probably be outdated by tomorrow. But the thing is that this software, the AI software, is not magic. It doesn't just spring into existence. It's not a dark art or something. It's software like a lot like any other. It's written by teams, yes, of humans, and not by robots and androids. They use conventional software development tools. It does have some features which are not present in most software, but are definitely not unique. The things that people use to write AI are present in certain rare types of software as well. And of course, like any field, many libraries, frameworks, tools, and whatnot exist to help out. What's a bit different in this field is that the vast majority of AI software is done in Python. And Python, the vast majority of this software, again, uses these popular Python frameworks, PyTorch and TensorFlow. But practically every existing machine learning framework has a Python front end these days. I cannot think of an exception. Why is that so? And the short answer is, meh. Who knows? The long answer is that for the majority of time, since the 60s or something, where the roots of AI can be found, this type of software has been done by, it has been more academic than practical. So it has been done by academia. And it so happened that academia was, I don't know, more comfortable with Python than anything else. And when it started to become more and more practical, all these things written already in Python by the academia people already existed. So it kind of naturally progressed into what we have these days. So yeah, personal opinion time, prepare your tomatoes. Is Python the best language for machine learning? Nope. Is it the worst language for machine learning? Well, no. Bologna is definitely worse. But I think it's down there. The thing is that with any duck-type language, extreme care has to be applied by the programmers in order to have things working. Many attempts to write big pieces of software in Ruby or Python or JavaScript even have shown that duck typing can be used to shoot yourself in the foot really bad. And with the popularity of this type of software, the software that gets written in Python gets bigger and bigger and bigger, and this can be problematic. And Python stacks these days are definitely a mess. So every joke that you've heard about Node.js can be applied to and the web stack can actually be applied to the Python stacks these days. They have their plethora of package managers, environment managers, and of course, I mentioned academia. They do like their notebooks, and they write scientific code, and we all know that scientific code is just a nice way of saying bad code, right? So the reality is that the vast majority of modern AI software is prototype-grade spaghetti. So, and now this is not personal opinion, this is objective truth. Python is slow. And of course, many people would say that, no, it's not slow, definitely not slow. This Python program right here is faster than its C++ equivalent. We've seen this many times, and that's true. If you write a naive program, if you write a program in C++ naively, it will actually very often be slower than its Python or JavaScript or even a Ruby equivalent. Because, for example, if you use map, every new node in the map will lead to a new location. The standard library does not help you manage these things. So yeah, but you can be pretty sure that if you write a piece of software that uses studmap, or a piece of code, I guess, it will be slower than if you write it. It will be slower than its Python or Ruby or JavaScript equivalent. So PYC should do it, right? If you've tried Python, you know that PYC actually helps you boot, but it does not actually improve the performance. And also, you know that być in Polish means to be, right? But byt, little known fact, in Polish means to deal with the excessive amount of bloat a Python stack leads to. So also some arguments that we've heard is that it's the most optimized interpreter there is. It's not V8 by no means, and V8 is probably the most optimized interpreter we've seen. JIT compilers work. There exist Python JIT compilers that they're not widely used. They can help in certain cases. But the main argument here, I guess, is that it doesn't matter that Python itself is slow. The low-level underlying framework, which does the actual computations, will do the work. And that's true to an extent, but the problem with these frameworks is that they're opaque. So you cannot control, you don't have fine-grained control over the data flow. If you want to make some tweaks, if you want to either tweak the way the data flows through the framework or how it performs certain computations, it's hard to impossible. You have to touch the framework itself. And this is very similar actually to using game engines. A game engine is typically a black box. It might not be, it might be open source or something, but it might as well be a black box because it's very hard to actually make the changes you want. And that's why so many, for example, game developers have chosen to create their own purpose-built engines which are suitable for this type of game or even for this specific game. It's not like a reusable engine or something. But also with these frameworks, them being general as they are, the bloat intensifies. So they are designed to do everything, but you will most likely not need everything. So something good about Python. Yeah, it's good for prototyping, sure. And also slicing is pretty neat. Slicing in Python, I guess, is a pretty neat feature. But similar syntax is coming to C++. Kind of, sort of similar, I guess. Now, of course, I'm not the only one with these types of problems, right? So many people have noticed but even I haven't noticed everything that I just said. I learned it. But many people have noticed these things. And they've tried to come up with alternatives. And sometimes they use CUDA for machine learning, so C++. They use OpenCL for machine learning, so C++. They use Metal for machine learning, so C++. And Objective-C++, sure. Or Swift, yes. They use Vulkan for machine learning, so C++. But OK, Vulkan can be used with many other languages. You can also do it yourself if your platform has this requirement. You can write code for the CPU. And basically anything but Python is suitable there, any low-level language, I should say. There's this thing coming, that modern thing called Mojo, which is essentially a framework. It may perform better than other frameworks in certain situations, but it also may perform worse, even though the authors have claimed like 10,000 times faster than its Python equivalent. And yes, for this particular example, it might be true, but for this particular example, it's 2 times slower. The fact is that I don't know much about Mojo. I've seen bits and pieces here and there, but it's definitely not magic. So it's not like something that cannot be replicated if you want this type of performance. And of course, this being the big thing in software right there, alternatives come up every single day. Let's have a crash course in ML. And I should make a confession. I lied. I'm not an ML engineer. Now, actually, my title is ML engineer. But I only started, as you can see, this is an exact copy of the second slide, in 2003. So last year, I had absolutely, well, not absolutely, but almost no idea what it took to write AI software. I started dabbling in the field in early 2023, so less than a year ago. My title is an ML engineer, but I cannot, in good heart, call myself an ML engineer. I do a lot of C++, yes, for more than 20 years. I'm old. I do a lot of low-level stuff, yes. I've written GPU code a lot, and code for not only general purpose, but being in games, I've written a lot of graphical code for GPU. Being in games, I have chased microseconds and even nanoseconds at times. But machine learning, I don't know. But anyway, you're here, so this is my perspective. There are a lot of ML techniques, but we won't deal with those. We will focus on neural networks. Neural networks are pretty interesting. They have a very interesting history, and you should check it out, but we won't today. OK, well, what is a neural network anyway? It can be said that a neural network is a function, much like this one. This is a classifier. So we have a predefined set of things, and we give it an input, and it will say which type of this predefined set this thing is. Well, to be more precise, it will likely return us a list of all possible things and probabilities, and hopefully one of these probabilities will be close to 1, and the rest will be close to 0. What is GPT? It's a function. You give it a prompt, a function, a string, and it outputs a response, a string. Well, to be more precise, it actually outputs one string token. Anyway, no details here. It outputs one string at a time, so the response comes in multiple bits and pieces until it says, okay, nothing more to say. But it's still a function. Okay, that's obviously not good enough. A neural network is a computation with parameters. Okay, so the classifier function. We give it a bunch of parameters, and based on these parameters, it will do its classification. For example, if you've probably heard about Llama 7B or this type of thing, dash 8B, 34B, and whatnot. This actually means the number of parameters it takes for this particular neural network to run. For Llama 7B, it takes 7 billion parameters. So in the previous slide, this vector here is 7 billion floats, and we can run GPT with it. Neural networks need to be trained. This is roughly, it can be said that training a neural network is basically solving the function that the neural network represents with respect to the parameters. So you want to find parameters which produce results that you like. It is done with gradient descent. You have to be careful of learning rate. There are many techniques in training neural networks, but we won't deal with any of those. We are here to do the gist of it. Neural networks need to be designed. And remember how I said this type of software is not magic? Well, I lied, it's magic. Designing neural networks is basically magic. It's, well, yes, it is mostly indistinguishable from fortune telling. People who design neural networks have years of experience, and a lot of gut feeling is involved. And it seems that most of their knowledge of designing neural networks is untransferable. They cannot teach you how to design neural networks. They rely on their experience, their gut feelings, but we should probably design a neural network to teach us how to do neural networks. Currently, that's the state of things. And also, to these flashy types of software that you've seen for the past year and so, take literally millions of hours to train. So it's not that accessible, I guess. If you want to train your own GPT, you will only need several million hours on your home computer, and you'll be done. Great. So we won't deal with this too. Basically, neural network applications are done like this. First, they're designed, magic. Then they're trained, not magic, but not our topic today. And then the other thing that they do is called inference. So basically, inference is the opposite of training. Once you've trained your neural network, you give it some inputs, and it produces outputs, and that's called inference. And there's this modern thing that is supposedly the great future of neural networks. It's inference on the edge, or edge inference, which is having your neural network run on your own device. So doing inference, not training, but inference on your handheld or at least your laptop, not relying on some kind of cloud servers out there to do this for you. So, okay, what is a neural network? We still don't know what a neural network is. It's of course, it's in the name. It's a network of neurons. And what is a neuron? This is a neuron. This in the red circle is a neuron. It has weights, a bias, and probably an associated so-called activation function. And what it does, it takes some input, so the same number of input values as the number of its weights. It multiplies the input values by the weights. It adds the bias and calls the activation function on the result. Simple, trivial. Neurons come in layers in neural networks. So neural networks have layers. And see these vertical bars, those are the layers. So the B1 layer in here takes the input, does the multiplication, and then its output is used for the next layer. And deep neural networks are networks that have more than 2 layers. And we'll see how this is interesting later. But that's, again, trivial stuff. let's take a closer look at one of these layers. So again, we take the inputs, we multiply the inputs by the weights of each neuron, and we add them up together. You should know this. It's hello matrix multiplication. If you represent the weights of each neuron as a row in the matrix, and you multiply that matrix by the input represented as a vector, you will get the exact same thing. Then you add the bias vector, and then you call the activation function on the output. And that's how a whole layer of neurons is basically calculated. And that's pretty much everything. That's what neural networks do. They multiply matrices, but a lot of them. So what layers come in types? What you just saw was the linear layer, or the dense layer, or the fully connected layer. I like the term fully connected because it's fully connected. Each neuron is connected to each input. And it's true that almost all types of layers can be represented as a fully connected layer. But it's not very optimal because this leads to these huge matrices that take a huge amount of time to multiply, even for inference. So for efficiency purposes, people have designed not fully connected layers. You can imagine that the not fully connected layers has, for example, zeros on certain weights, and it's equivalent to a fully connected layer. For example, there are convolution and pooling layers, normalization layers, attention layers. But layer actually is pretty fuzzy because some people, for example, prefer to, you remember that it's a matrix multiplied by a vector plus another vector. Some people, for example, prefer to call the first operation here a multiplication layer. Then adding the bias is an addition layer. So when you hear layer, it may actually mean a part of what I just said is a layer, or even multiple layers combined together. For example, attention layers can be viewed as multiple multiplication layers applied together. Anyway, layer is just a part of the computation with a name. Named thing. We should learn those names in order to do machine learning with neural networks. And this resource here, the neural network Zoo, has a lot of information of the most popular, at least, names and types of layers. So I mentioned the activation function a couple of times, but why do we need activation functions? Remember deep neural networks? So a deep neural network is a neural network with more than 2 layers. So input, output. So you can view this even as a single layer. Anyway, without an activation function, imagine all these layers. So no activation function. We multiply, add. So what is multiplying a matrix by a vector? That's transformation. Add, translation. So then we do another and another and another, and you remember what this is. It's concatenating transformations. Not necessarily affine transformations, but still transformations can be concatenated. So if we don't have activation functions, we can concatenate all the layers into one, always, without an exception. And we will get a single layer, so a shallow neural network of sorts. And long ago, people decided, before they thought of activation functions, they decided, this is it. We don't need layers. We can have a single layer, which is concatenating all the required transformations together. But then they found out that this doesn't work. This doesn't produce interesting results. So they devised activation functions, which are non-linear. So, for example, the most popular activation functions, or most popular activation functions of the easy neural networks are sigmoids. The logistic function, the hyperbolic tangent, and this SMHT is the Sobolev modified hyperbolic tangent, which I don't even know what it is, but I want it to sound smart. There's ReLU, which is if you've lived your life thinking that activation functions shouldn't be linear, your mind will be blown when you see what ReLU is. There's Leaky ReLU. We don't need to deal with those. Let's look at a particular non-fully connected layer. It's convolution. So, in this case, neurons don't depend on the entire input. You can think of the neurons in a way as the right kind of image, and the input is the left. So this is much smaller than a fully connected layer. So orders of magnitude smaller in terms of computation. And it is also one of the rare cases where academia has actually come up with an explanation of why this type of layer actually does something. It's basically, weights are shared. It's basically finding features. You can think of a convolution layer as finding features in an image. For example, if you want to teach our neural networks to see whether something is a cat, we can have a kernel, in a way, which, for example, the yellow one could check whether something is an ear. The blue one could check whether something is an eye. The red one could check whether something is whiskers. And this way, you combine features for the image. Again, it's just matrix multiplication, but much smaller in this case. And you combine these features into the so-called feature maps. Pooling, which also often comes with convolution. It's basically having parts of your input and topologically neighboring parts of your input and taking one of those values or the average of those values. It can be basically viewed as collecting important features. So we decided that this part here is very likely to be an ear or whiskers or whatnot. And when we collect its neighboring parts and we say, okay, we take the maximum, so it's very likely that this part of the image roughly has whiskers in it, for example. Again, one of the rare cases where academia has come up with an explanation. I actually don't know whether they came up with the explanation retroactively, or they first thought of it, ooh, that's a good idea, and then they tried it. I don't know. Probably the first one. Okay, so what is a neural network? A neural network is a collection of layers, whatever that means, which define a computation. And that's basically it, a computation, number crunching. Time for some more terminology. Tensors. You often hear of tensors when we often hear of tensors when we talk about neural networks. But don't be scared, it's not physical tensors with tensor analysis and whatnot. It's just n-dimensional arrays. Much like stud vector is not actually a vector in terms of vector arithmetic. It's not used to represent direction or anything. That's the term tensor in this case is just used to represent an n-dimensional array. It has a shape, which, for example, this two-dimensional array has a shape of 3, 2, so 3 rows of 2 columns, or maybe it's in some cases 2 columns with 3 rows. Different frameworks have different opinions on the matter of how to arrange the columns and rows and whatnot. But also keep in mind that it can be more than 2 dimensions. Tensors usually have broadcast, so a lot of times you hear about broadcasting. So broadcasting basically means to disregard shape in certain situations. So for example, a function on a tensor will be interpreted by calling the function on each element of the tensor. Adding 2 tensors of different shape will broadcast the smaller one to the bigger one, if possible. Otherwise, for example, it will throw an exception. So if we think of tensors as simply n-dimensional arrays, we can have tensors for weight, bias, and layer. So the layer output, in this case, the layer output of layer 5, a fully connected layer, is multiplying the tensor 5 for weights by the vector, also tensor, because a vector is like a specific case of a tensor, with the previous layer's output, and then adding the bias, and calling the activation function on this. But basically, this is tensors, basically n-dimensional arrays which are used to hold our parameters. What is a model? I didn't know if I said the word model so far. I tried not to. I may have. But what is a model anyway? It can be 2 kind of sort of different things. Unfortunately, the terminology is such that, depending on the context, people may mean the computational sequence it needs to perform to calculate a neural network. So basically, in a way, the topology of the neural network. And in other cases, people may mean the actual collection of tensors, the actual collection of parameters, which is used to compose this neural network. So, for example, Llama is a model which does this sequence of computations. But Llama 7B is an instance where this sequence of computations should be done with 7 billion parameters. Llama 128M is the same sequence of computations, but with smaller tensors. So the first should be a model, the sequence of computations. The second should be the collection of parameters and their size. So let's take a look at a model, whatever that means, called LeNet. It's pretty old. It's one of the first things that you will do if you ever try to do neural networks, because it's also pretty simple. And it can run probably on your fridge these days. This is the MNIST dataset, which is used to train it. These are basically handwritten digits by humans. What LeNet does is basically have an input, which is an image 28 by 28 pixels, then collect some feature maps with convolution, then pool those feature maps, then do some more convolutions, more pooling, and then produce an output, which is a single vector. And it's used to classify individual handwritten digits. If you remember, so I don't know how old you are, but a long time ago, suddenly, on forms that people filled up manually, dividers started popping up. When you fill a number, you fill each digit in a single slot, when manually handwritten digit in a single slot. And that's because LeNet got really popular. And it was a really convenient way of actually reading handwritten digits and transferring them to computer information. But it only can be used to read a single handwritten digits, and that's why people introduced dividers on manually written forms. Anyway, this is LeNet written in Python in PyTorch. It's pretty simple. So as I said, convolution, activation, tangent, the hyperbolic tangent, average pooling. So we don't take the maximum result of the convolution. We take an average, the average of the convolution, another convolution with more features, collecting more features, another hyperbolic tangent, another pooling layer, and then we have a fully connected layer for the end. And how we calculate it? We calculate the convolutions, we calculate the linear, the fully connected layer at last. And then in order to produce the probabilities for each digit, so this outputs a 10-element array, where each element is the probability of the input being this precise digit. We do a softmax, so we can kind of distribute the probabilities properly. That's what LeNet is. And this is the exact same algorithm written in a popular these days C machine learning framework. We have the convolution, and again, in this case, biases are manually added to a separate layer. So this add here is the bias the adding of biases after the convolution. We have an add. We have the in this case we also need to manually do the broadcasting. Repeat here is this. We have the hyperbolic tangent, another pool, another convolution, another adding of biases, hyperbolic tangent, pool, reshape in order to have the output as a single dimensional tensor. Fully connected layer multiplication, fully connected layer biases, softmax. And that's it. It's trivial. Why it works? I'm sure when they designed it, they didn't they could have expected it to work, but they didn't know whether it would work or not. Anyway, so this is how basically how AI software is written in a way. And it presents us with some practical challenges. As I said, it's all number crunching. So the challenges that we see in AI software are number crunching challenges. Since we're dealing with floating point numbers, and GPUs are typically orders of magnitude more efficient in doing floating point number arithmetic, basically GPU is the way to go. And if you can, so for example, if you target devices which have GPUs, this is the most efficient way to calculate stuff. And this is true for all number crunching. If you don't have GPUs available, you should try to make the maximum possible use of your CPUs. And in cases which are very rare, you can have them both run at the same time, the CPU and the GPU. Basically, it's all matrix multiplications. Like the vast majority of these computations are matrix multiplications. So you would have to have some kind of GEM algorithms. BLAS is a GEM library, which it also does other stuff than general matrix-to-matrix multiplication, but it's a library which has many implementations for many platforms, many targets, but it's not always the best one. It's not always perfect. In some cases, you will have to create your own multiplications, which are suited for this particular shape of the input. Cache locality, as any type of software which wants to run fast, is also critical, and you will have to keep it in mind. In many cases, the bottleneck will actually be memory bandwidth. It won't be the computation. The GPUs are so fast to compute these inputs that the problem will be that they cannot get the required data as much as needed. So in some cases, you will have to do reshapes or reorganizing data in order to allow the maximum possible flow, the maximum possible bandwidth of GPU memory to your computations. And in this case, yeah, Metal and M2, the M2 Apple hardware are actually a pretty decent choice for machine learning because they have a lot, hundreds of gigabytes of memory accessible with a very extraordinarily high throughput. So it may be that, for example, your model can be calculated much faster on, say, NVIDIA GPU. It has a higher throughput than the M2 hardware, but even the largest NVIDIA GPUs have tens of gigabytes of memory, right? Whereas M2 has almost the same memory throughput, but it can have 200 gigabytes of memory, right? So it can fit a larger model. And quantizations. Multiple times I said floating point numbers, but the reality is that 16-bit floating point numbers are practically the norm these days. So almost all cases where neural networks are computed, 16-bit floating point numbers are used. And exotic quantizations exist too, like to 4 bits, 6 bits, 3 bits, even 2 bits. And certain experiments exist where a 2-bit quantized framework actually performs really decently well. Why do we want quantizations? Memory throughput. If your floats are 32-bit, even if it takes the same time to multiply them as 16-bit or 2-bit floats, in most cases 2-bit floats will be a bit slower. Well, not 2-bit, but say 6-bit float will be about the same speed as 16-bit float, but the thing is it's smaller. So you can allow more memory throughput. So basically you have to find a balance between the speed of the computation and the speed of the memory, which is provided to your computation. Fusing kernels is also a thing, of course. Basically, fusing kernels means that if you have multiplication and addition, in some cases it will be faster to do it at the same time as opposed to first doing the multiplication, then adding the bias, say, to the output. That's what fusion means. So this is the most trivial example, like fusing many complex computations together is also oftentimes needed. Streaming. Streaming is basically what my GPT example was. Streaming is not taking the output of your neural network when it's done, when the computation is done, but running bits of the computation, a bit of the computation, then getting the output at that point, providing it to the user, and then running another computation. This is what streaming basically means. And facilitating this can be a challenge. I mentioned tweaks before, and yeah, they do come often more than you think. Of course, quantization is a tweak. If you're, say, PyTorch, it supports 16-bit floats, of course. It is the norm. There are efforts for it to support 8-bit floats, but if you want 6-bit quantization, there's really not much else out there besides, say, GGML. Or you can write your own. It can be better, theoretically. Reshapes are often needed at certain to facilitate the memory throughput. Custom kernels are in, for example, if you want this particular type of fusion, will be you will have to write something custom. Sampling and resampling basically is again a cache locality problem. So how the algorithm takes the input data, which parts of the input data it reads at which point of the computation. And in some cases, this again can lead to microseconds, but again, some kind of optimization. So say you wanna do this. How do you start? So first, forget about training neural networks. You will eventually dabble in training, I guess. I still haven't. But focus on inference. This is the most, I guess, rewarding part because you see the results, but also the most practical part, I guess. Training takes millions of hours. If you create your marvelous training algorithm, you will probably wait for hours until you see whether it's produced a decent result. Whereas inference typically takes seconds, right? Or parts of the second in some cases, depending on the neural network size. And yeah, try to implement the simplest model in the most naive way. So forget about simmed GPU, forget about, just write it in the most simple way of how you do like programming 101 matrix multiplication, for loops and everything. You will get a feel for data flow this way. And also, unfortunately, yes, you will have to play with Python. Try to run the Python computation, the Python version of this model that you found. For C and C++ specifically, there are a lot of choices. I mentioned PyTorch and TensorFlow as Python frameworks, but they also have a pretty decent C++ interface as well. They suffer from the same problems that I've mentioned, like they're rigid, opaque, and whatnot, but they can be useful in many cases. GGML, I also mentioned, is a C library for machine learning. It has some pretty exotic quantization. It has different types of backend, CPU, Metal, CUDA. Vulkan is in progress. CTranslate 2 is a CUDA neural network framework. It's much smaller than PyTorch and TensorFlow, so you can actually play with the code. NCNN is from Tencent. The Chinese people have probably the best Vulkan ML framework there is. And of course, NVIDIA, this being the glory days of NVIDIA because of this, because they have good GPUs and they invest a lot in machine learning software. They have many libraries written for machine learning. But for example, why I say bloat, TensorRT takes about 2 gigabytes to install. So why? I don't know. Probably because of custom compilations, because it's closed source, like custom compilations for different types of hardware or whatnot. It's huge. It's bloat mostly, probably. So if you want to see existing implementations of different types of neural networks, you will have to start with Hugging Face. So Hugging Face is a website which has a lot of models, a lot of data sets if you want to do training. It has these things called spaces, which are basically UI to test and play with different models. GGML has a lot of examples. Llama CPP is a popular implementation of Llama written with GGML. Llama 2.c is a popular implementation of Llama written in C, where you can actually check the data flow, and they're relatively small and manageable for a single person. Intel has come up with their own library for machine learning, but it has a lot of examples in there. And of course, NVIDIA have examples for their libraries, many, many examples for many, many different popular models. So practical steps. Find a model. Look at the model description, if available, or at least look at the Python implementation. There definitely will be a Python implementation. Everything has a Python implementation these days. Implement the tensor operations. that you need in your preferred way. If you have problems, if you don't feel like you're doing the right things, it's usually pretty easy to check, for example, the outputs of each layer from the Python implementation to compare them with the implementation of the same layer with yours. So this is how you break down basically a model, but layer by layer. And that's basically it. Then try to be faster than the Python implementation. And you will be surprised that that's not such a tall order anyway. Try to be faster on the CPU. Try to be faster on the GPU. Why not? Do more models. That's basically how you enter the field. For the real world, these are challenges that if you enter the field and you start doing this as a job, this will be some things that we'll need to consider. You will likely enter a project that has an existing Python implementation, but it's not ready to be completely rewritten, say, in C++. What you would typically do is write a plugin for Python or PyTorch or TensorFlow, which will start basically handling stuff from the inside out. First, you do several tensor operations with your code, your plugin, then more and more and more, until you basically devour the Python implementation from the inside out. Profiling multiple languages, multiple platforms can, of course, be a problem. And given that this is software like any other, there's a lot of periphery software which is not strictly related to machine learning, to the model itself. Well, it is related to the model in terms of output and input, but it's not machine learning as it is, which can also benefit from being rewritten in something better than Python. And in these cases, many of these cases, we have code written in pure Python without relying on any existing framework doing such things. Of course, you will have to consider horizontal scaling. And again, it's software like any other. It has its own issues. It has its own separate things to consider, separate things to do, which are not directly related to the main part of the software. So anyway, if you like number crunching, if you like chasing those micro and nanoseconds, if you like doing magic, and if you dislike scientific code, you are needed. It's the next big thing. We can ride the hype wave. These slides are here. Thank you.
Thank you very much, Borislav, for a really, really inspiring presentation. So if you have any questions, then please raise your hands and ask them.
Hello, and thank you very much for very inspirational presentation. I have a question about this GPU processing. My question is that do you think that moving from Python to C++, will this cause to independently choose this GPU hardware accelerator? I mean, currently we have NVIDIA because it's we are using this CUDA as a layer to implement the Python packages and libraries. But the prices are very high. I have seen that some steps taken by AMD to try to compete with NVIDIA. My question is that if we are going to use C++, will this limitation will be relaxed or
well,
somehow?
As much as your experience and choice of hardware. So, okay, first of all, PyTorch do have an AMD. What was the ROC something?
ROCm.
ROCm implementation. Yeah. Then AMD, seeing that CUDA rules the world these days, have developed the HIP API, which is basically equivalent to CUDA, but the functions have different names. What you can do with HIP is define a bunch of macros which define AMD something to Q something and run the exact same code on AMD hardware. So that's basically possible these days. But even if you're considering exotic hardware, this is one of the reasons that you would even consider leaving Python. You will have a broader, I don't know, possible types of hardware that you can support if your experience and your expertise basically allow it. If you, the thing is that that's not all. it is very likely that popular Python frameworks will start to support hardware if it gets more accessible and more cheaper. For example, people want to save money. What the core purpose of ditching Python basically is having fine-grained control. This is sometimes it will lead to a 10% optimization, but consider that the model these days is typically used by, say, thousands, hundreds of thousands of people. These 10% basically reduce cost. It will reduce the time it needs for the time paid by the company for the cloud, or it will make a better user experience if you optimize even a tiny bit of the computation.
So I can conclude that it is better option to go on with C++ than
or another low-level language if it allows you to make better use of the hardware. That's basically it. Having finer-grained control over the hardware. This is where the current, the current goal is for everyone.
Okay, thank you. And another question for C++, like what you mentioned, PyTorch and TensorFlow has already this C++.
They are written in C++, and they're like the API are exposed to C++ as well.
My question is that are they rich enough from library perspective that, for example, if I want to, let's say, use a specific kind of model with a specific kind of algorithm, is it rich enough, comparable to Python to use C++?
It is exactly comparable to Python. Even your code will look very much similar if you write a C++ implementation of a model with PyTorch. The code will look very similar to the code that you would otherwise write in Python, and have the same limitations.
Thank you very much.
Yeah, hello.
Hi.
Thanks for the talk. My question is, there was recently some talks and announcement about regulation in terms of AI, machine learning from USA and China. Do you have any thoughts about it?
Sorry, can you repeat that? I didn't catch that.
I mean, regulation and some standardization, limitations.
That's the philosophical and political part of the talk that I'm skipping. There are regulations coming, yeah. It's every time something becomes the next big thing, there's a lot of regulations involved, and then the stuff that we developers oftentimes find bad. And currently things are looking grim, but hopefully it will not end up being this way. Let's not turn this into a political conversation, but yeah, we can talk later about this.
Okay, thank you.
Okay, so thank you very much for your questions, and thank you very much once again for the presentation. So here is the QR code where you can rate our speakers, so I encourage you to do that.
Thank you.
And right now we will have a lunch break, so thank you very much for the attendance, and I want to remind you that there are plenty of great restaurants nearby, so you will find something you will like, and see you soon on the next presentation, which will be held at 2 p.m. Okay, so welcome back after the break. I hope that you had an amazing and delicious dinner. And now it's my honor to present our next speakers, Robert Synoczek and Szymon Madej. Robert is a FPGA design verification engineer at the Nokia Kraków Research and Development. He works on innovative projects in the field of machine learning. Machine learning used in the design and verification of 5G telecommunications systems. He also conducts research in the field of machine learning implementation on SoC FPGA devices. He completed his master's studies in automation and robotics at the Faculty of Electrical Engineering, Automatics, Computer Science and Biomedical Engineering of the AGH University of Kraków. Szymon. Szymon is a FPGA engineer at Nokia Kraków Research and Development. He works on creating innovative projects in the field of machine learning and FPGA technology in telecommunications. He also implements scenarios for verifying new FPGA functionalities for 5G telecommunications systems using the System Verilog and UVM languages. He completed his engineering studies in electrical engineering at the Faculty of Electrical Engineering of the Wrocław University of Science and Technology. Szymon and Robert, this stage is yours.
Okay, thank you. Hello, everyone. My name is Szymon, and together with Robert, I will talk a little bit about functional verification, about machine learning, and also about co-simulation. This presentation is graded as 3 out of 3, level so advanced, but don't worry, because we are FPGA engineers, and we are used to explaining difficult things. For example, when we try to explain our jobs to our family or friends. A few words of introduction, functional verification, co-simulation, and also machine learning, a lot of topics. But in short words, we will try to present an innovative way of improving, of accelerating the process of designing digital electronics. So we will talk about functional verification, the challenges in functional verification, its place in the ASIC design flow, and also we will talk about 2 ingredients of our solution. So first, co-simulation approach, and Robert will talk about the machine learning part. Okay, so functional verification as a part of the design, ASIC design, so design of digital electronics. Let's say that we are a large company and we want to design a piece of electronics, for example, a controller for a washing machine, something like that. We need a plan, we need a specification, we need to know what we want to do. So we want a specification and description. Then we need a high-level approach to the architecture, so some kind of schematic. Then it's time for coding, done in hardware description languages like Verilog or VHDL. It looks like programming. Those are lines of code, but it really isn't. So it's quite difficult to explain, for example, to our families. And then functional verification. So the main star of this presentation, a way of ensuring that the design hidden behind lines of code will behave as intended, finding bugs or happy little accidents. Then there are a few steps that are done with the help of automatization tools like synthesis, so translating the code into a netlist of registers, logic gates, also placing and routing. So now we need to take this abstract thing, this netlist, and place it on the real resources. Then also static time analysis, because the digital design is a fine machinery of synchronized things, and everything needs to be well synchronized, like in a Swiss clock. Then another stage of verification, but with the consideration of physical phenomena, like delays, electrical current. And then manufacturing, that's last step. So back to the functional verification. Functional verification is done on the lines of code, on the abstract thing, on the design under test. We call this because this duty. We apply stimulus to this design under test, things like signals like clock, enable signal, input data signal, reset, and we observe results. And of course, we need to compare the results with some golden reference from some mathematical model, for example. And then we collect a measure of coverage. Is like a scoring for our testing approach. So we need to maximize the coverage of the test bench as soon as possible, as quickly as possible, using as low tests as possible to test everything. There are three main approaches to the functional verification. First is direct testing, so based on the sheer expertise, based on the knowledge. We know what we want to test. So, for example, we need to test a research stage during the runtime, for example. Then pure random approach, so literally throwing the input data into the design under test. Very naive approach, but this is necessary for me to explain the last approach that is widely used, constrained random. Basically, it is a randomness, and on top of this randomness, we have constraints based on the sheer expertise. So, for example, we can change data, input data randomly, but it doesn't make sense during the reset time. So we have a constraint on top of the randomness. That's a widely used approach. Functional verification constraint, random functional verification is a very good thing, but nowadays it's not enough. So we need to find a solution to improve this furthermore. According to the Wilson Research Group and Siemens EDA report, functional verification is very time consuming because it takes like 40 to 50% of the time spent on the whole project. Moreover, designs are getting more and more complex, so functional verification is taking more and more time. We need to find a solution because we are losing money on the functional verification. So the first ingredient of our approach is usage of co-simulation. Quite simple idea, actually, because this is a usage of some external environment, simulation environment like MATLAB, to improve the way of creating test cases or creating the reference data. In our example, we use a physical uplink shared channel IP estimation block, but that can be anything. The design under test can be anything. And we use MATLAB simulation, namely the 5G Max used in Nokia, that is based on the MATLAB language. And we also need additional wrappers between the simulation environment and the test bench with the design under test. And also we use ExecMan tool, a very, very good tool for automating processes done in functional verification, the managing of test cases. The whole flow is done with the help of this tool. So actually that's like a first ingredient. And Robert will talk about the machine learning, which is like a real deal in this presentation. So Robert.
Thank you, Szymon. So, hi again. My name is Robert. And I'm here to present to you the recently published, actually, machine learning-based test selection for our constrained random verification environment. I mean, recently published. It was literally published and presented yesterday on the Design and Verification conference in Munich. Which I came from over this night. So, by a bus, yes. So let's start with a short introduction to artificial intelligence, machine learning, and deep learning. So most of you maybe have heard the word AI/ML used as a buzzword. So basically, those are three different domains, each one in the previous, which all hold one meaning, so a program that can learn and reason in a way similar to a human. So you can start with some basic algorithm for predicting the weather, or even like a game bot that tries to mimic another player. So that would be what we mean by artificial intelligence. Now, a smaller subgroup of artificial intelligence would be machine learning. These are specific algorithms that have the ability to generate and approximate models of a problem. It's basically an over-parameterized approximator for a problem. With enough data, it can easily make some basic predictions and or make some results without being explicitly programmed by a human. And then inside that, because we all hear about neural networks, there's the domain of deep learning, which utilizes deeper neural networks in the machine learning methods. So why did we decide upon calling this machine learning based? It's quite simple because we have tried many methods during the development of this project. So the premise was quite basic. We had a parameter generator for the simulation that Szymon mentioned earlier. And, well, because it's constrained random verification, you start getting a lot of very similar cases. So that's why we decided to add a test selector in between the generated test and the simulation that could decide which tests could be discarded and which ones are interesting enough to be simulated and make the functional coverage go up. So we base this on the assumption that if the tests are different enough, they should technically hit new functional coverage groups. I'm a big believer in showing also the wrong results during a machine learning project because you always hear about the successes. So to lead to a success, you have to go through quite a deep trench of wrong answers. We basically started with supervised learning. We made a data set of 2,000 tests. The sequence was randomized, labeled by a human and or by a script later. The human labeling part was just too time consuming. Took us almost a week for all those tests. And we tried some basic methods from machine learning, so support vector machines, decision trees, random forest, and even some simple neural networks. Later in time, we tried to make those 2,000 tests into a few random sequences to try out a LSTM neural network. That also didn't work. It just found a cutoff point at which it decided that every test is not interesting and you should just finish your testing. So this is the moment we thought that, yeah, maybe we need to change our approach. We tried some unsupervised learning just to, lower the amount of dimensions and see if any patterns show up. So that was the methods like factorial analysis of mixed data, t-distributed stochastic neighbor embedding, which shows you really nice graphs, and uniform manifold approximation, which is basically something close to the previous method. But that was the moment that we noticed that, yeah, that also doesn't work. We have highly overlapping clusters for the already labeled data, and we were stumped. So that looked like the end of the project. But then we noticed that maybe we're trying the wrong approach. maybe this problem isn't just a simple binary classification problem where you think that, yeah, one test is interesting, one isn't interesting. No, it actually turned out that you can redefine this as a anomaly detection problem, because you start to look for tests that are totally different. So you get an outlier that is somewhere outside the group that you usually generate. So he's basically an outlier, something you could call an anomaly. This was the moment we tried an autoencoder-based approach, which was still a simple neural network, some fully connected layers, some leaky ReLU as activations, and all the layers, almost, 5 of them, had their sizes based on the input feature space. So how many parameters we were randomizing at one time. And these input parameters had to also be normalized because the neural network would work better that way. Just the basic loss function, mean square error loss function for training. And the important part here is that we processed tests in batches. So almost like few to a few hundred tests at a time, depending on your configuration and how big your design was. So the way it worked was that you generated some simulation parameters at the beginning. So that should be to your left. Those were normalized, put into the inputs of the neural network. And now the autoencoder is called an autoencoder because it first compresses your input into a latent space, so the smallest layer in the middle there, and then tries to recreate it based on the training process. So basically, if it already trained on some inputs, it saw their distribution, learned about it, and it gets a new test, or one field in the input is totally different from what it ever saw, it cannot remake it the same as previously. So you get a bigger error at the end. You measure that error, and now you threshold based on that error. So you have a group of, we suppose, 20 tests. You sort them by the error ratio, and now you know that if the worst recreated tests should technically be the most different from what the model ever saw. So then the thresholding happened. You took those worst recreated tests, kept them for simulation, sent them onwards through the system, and discarded the rest. About that thresholding, we have tried 2 basic methods. So the most basic is you just pick some threshold of, for example, you only take the 25 worst recreated ones and keep them. That was the fixed threshold. Shimon also found a method where we could just keep the training mean square error from the previous iteration and use it as a threshold, because that's probably the error threshold at which the training data holds. So the training data consists of all the tests that it already saw, so that would be a logical conclusion. We named it MMSE, so moving mean square error. And now putting this all together, you had a test selector based on an autoencoder, a thresholding method. You would discard the tests that were recreated the best, keep the ones that were recreated the worst, and also keep them in some kind of data set for training, because with each batch of tests, you would add to that database and retrain your model. The flow gets really bad at one moment. I probably should skip this part. The only thing that we want to point out is that we kept only the 2 tools, so ExecMan and MATLAB, and we put the autoencoder at MATLAB. It gets complicated, so don't pay too much attention to this. The results, that's the most important part. We have tried a few configurations, so we tried a few batch sizes of 25 to 100 tests. We tried all the thresholding methods, so 2 fixed ones and 1 mean square error one. We ran all those simulations a couple of times to get the mean number of tests simulated each time. And as you may have noticed, each time we get a lower amount of tests simulated than the baseline. So basically we achieved what we were trying to do. The best out of all of them, in the case of the 25 test batches, you got an almost 43% reduction in number of tests simulated with the fixed thresholding method. And in the higher batch numbers, you got a 37% reduction using the moving mean square error thresholding method. And all of this is accompanied by an only 9-second retraining and prediction time for the neural network in that whole flow. So you lose almost nothing compared to the simulation time that takes 2 to even 16 hours for a single test. So now, after publishing our results, we can confidently say that this is the first state-of-the-art neural network and co-simulation-based functional coverage closure acceleration approach that was successfully used on a commercial IP. We're not done yet. We still have to optimize the flow. So we had some problems with the regression timing where running all those tools and running all those steps took a lot of time. So we got a big overhead compared to the baseline. So not much in the case of timing, but at least we got a lower number of simulations run, which equals a lower amount of energy used for those simulations. We still need to optimize the model further. So we didn't try out too many hyperparameter configurations. We also didn't try any deeper autoencoder models. These would probably work quite fine for bigger designs. And talking about bigger designs, we will test these approaches on the bigger, higher level physical layer designs that we have. And, well, that would be everything from me. Thank you. And if there are any questions.
Thank you very much. So now it's the time for question and answers. So if you have any questions, then please raise your hands and the questions will be answered.
Okay, hi. I have a question regarding the process of generating tests. Can you please maybe repeat how tests are being generated? Because I didn't quite catch it well.
Yeah, so the process of test generation happens in 2 steps with that co-simulation approach. I'll go back to that slide. So, it was here. So it happens in 2 steps. You first have a constrained random verification environment that generates the parameters for inputs to the simulation. So that would be the first step. You have some randomized amount of, not amount, but randomized parameters in a given amount that are sent to the 5G simulation, which generates inputs and outputs for the DUT you want to test, verify. And then those inputs and outputs are sent to the regression where the test is run, basically. So the randomization and the input parameters to the model happen before the simulation step, the data generation step. And later, when we add that test selector, you add that block in between the generation, the parameter generation, and the 5G simulation.
Okay, sure, thank you.
You presented that it's simulated on one particular IP. Is this algorithm could be used in different IPs without any adjusting, or you have to trim it to work with different IPs?
It's definitely easily generalizable. So if you have the problem arises when you have a different amount of inputs for each test. So that's a problem for an autoencoder model where you have to have a given amount of inputs. That's where you need to create the test bench so that it works with this model. But generally, if you have a set amount of inputs, you can easily input this DUT into this test bench environment and reuse it. This approach could even be used for some software testing, if I'm correct, because you also may randomize some inputs to a function, and if it's big enough, you can use that model to decide which inputs are the most different, which could maybe help you in covering all the functionalities that you want.
Okay, thank you.
Generating the parameters is the key here, adjusting the parameters.
We're open to questions. No question is wrong, so we only can give the wrong answers here.
Okay, so one more question, because it seems like this problem that you're trying to solve is basically, I don't want to make a mistake here, but I think it's like set cover problem from the computation theory, because you basically want to minimize the amount of tests that are needed to cover the certain sets of certain sets of problems that you're trying to solve.
Yes.
And have you been trying maybe another approach, because it seems that the anomaly detection as a way of choosing which tests which test is basically a proper test and which is not a proper test.
Mm-hmm.
For me, it doesn't seem very. I'm not saying that this is wrong, because it's certainly working, right, as shown, but I don't quite understand how the anomaly detection is the proper way of solving the issue you're trying to solve here.
So this actually came up during the conference as well, that there are some other methods that you could use for doing this exact problem. So for example, you have the synopsis solution that helps you when you have a DUT. It can basically choose the minimal amount of tests that need to be run to cover a given amount of functional coverage points. The problem there is that they only do it based on the inputs of the DUT. And that means that you cannot configure the tests as well as you could while using another simulation that could generate those inputs. So basically you have some sequential modules in your design, and now you're testing them based on a singular input instead of sequence of inputs. And that's where this comes in, because it can filter out those tests that could be those parameter sets that could, after the simulation, generate inputs that could cover new points. There was also another approach where you could technically train a model on a given design and then ask it to generate those tests, right? Mm-hmm. So that approach would not work with constrained random verification, because your trained model does not know about those constraints. You could filter them out after, but that's basically the same thing we're doing. So, yeah. you also have to ask the question of how big your design is. Because for very small design input spaces, finding the appropriate amount of tests is quite easily computation-wise. But for really big designs, you start getting into those hours and hours of waiting to get the not optimal, let's say, but the best found approach. So yeah, it's one of the methods. There are other methods you could try, but this is just more easily generalizable to other designs, where training another model or finding that set could only be used on one design and needs to be redone on any other. And this approach is learning based on the design during the testing. Yeah.
So like, if you think the anomaly detection approach makes sense, because different tests will hit different spots in the coverage subspace. So if autoencoder sees something that it's different, then we have a greater chance that this test will hit a different spot on this coverage space.
Yeah, right. Okay, thank you.
Thank you.
Hi, thank you for very insightful presentation. Can you please tell me how you implemented the phase of retraining? Because what I understood, it took with retraining and inference a little amount of time, so just 9 seconds, I believe. So, and also a follow-up question. So, if you could compare it to the initial phase of the training of this model, how much time did it take?
So we had two phases. We basically used transfer learning with a growing data set. So the initial phase was about 300 epochs, so really short because the amount of tests was also really small at that point. With each iteration, like you can see here, we append the tests that, so let's start with the initial epoch. That's when you do not make a prediction. The model is not trained yet. You put the model through training with the whole batch that you cut out. You append those tests, the interesting test data set. Then in the next iteration, when you do a prediction, you take those tests, they go to simulation and to the interesting test data set, and the autoencoder gets not retrained, but trained with the bigger data set this time. So more of a transfer learning approach where it could be found as a little nonsensical to not retrain it from the beginning, but you rephrase to the model that those tests that it saw some time ago are still important. So it recreates those tests that it trained on even previously better than those that it saw recently. So you can still, even when covering the same points, still hit them again to just, be sure that that functionality is covered enough. Yeah. Did that cover your question, or?
Yeah, thank you. I was also asking, just for curiosity, how much time did it take to first train the model with this first epoch?
That I didn't check. The 9 seconds is a mean amount of time, and it gets longer and longer with each iteration.
Okay.
So you may get
it's quite
from
fast.
Yeah, a few seconds to a few tens of seconds.
Okay.
Because those regressions were done for the lowest batches in 8 or 9 iterations. It's also helpful that we used the parallelization computation method for training in MATLAB, because that automatically divided the workload between the processors the cores that we gave it in the cloud, right? So
actually the simulation part is it takes longest.
Yeah, even if you go into minutes, you're still good because at the same time the simulation is running, and those simulations take a minimum of 2 minutes for such an IP, and for the bigger ones it will take hours to days even to do one simulation. So losing minutes on the model is no problem in this time scale.
Yeah. Thank you very much.
Thank you.
Is there any other question? Okay, thank you very much for the presentation. So now I want to encourage you to rate our speakers with the given QR code. And now we will have another 30 minutes break, well, sounding more than 30 minutes. And the next presentation will start at 3:15 p.m. Additionally, I would like to remind you about our available attractions, which I mentioned previously, so games and other things. once again, so please take your seats. And we will start in a few moments. Okay, so without further ado, I would like to introduce our next speaker, Agnieszka Szufarska. She is a sales engagement leader in Nokia. After spending years in 4G and 5G research, innovation, team leadership, and executive communications, now she spends most of her time transforming the complex engineering documents into customer-ready stories. Bringing simplicity and clarity to complex environments is what drives her in the workplace, and one of the 4 kids is who gets her up in the morning. Struggling every day to keep the work-life balance, juggling the many daily tasks, she still sometimes finds time for a walk in the forest or a computer game that she's a big fan of. Agnieszka Szufarska, the stage is yours.
Thanks, guys. I'm very happy to be here. My topic for today is the rise of modern IT professionals, and I am not that young anymore, so I am the perfect person to give you the right perspective into how life looked like 15 years ago, how it looks now, and then what we will see in the future. So starting on this perspective, that, as I said, I have, this is the rough outline of my career, the companies I worked for, but if you look at the logos here, it's only once that I have changed a job between different companies. In the beginning, 2004, I have moved from Gdańsk to Wrocław to start working for Siemens. So that was one job change between companies, and the rest is just the companies wheeling around me with the different name and brand changes. And to add to this complexity, you already said that this is 4 kids that we have. This is true, and then at the same time, I'm still able to have a dynamic career. So the way the environment for us IT employees changes is something that I'm very interested in, because it impacts my life every day, how I'm able to cope with my many daily tasks. So this is what we start from. What we will start from is looking a bit back, how life looked like when I was starting my career. That was 17 years with Nokia, and then we will come to the point now, and then we will look a bit to the future. So starting from looking back. In here, we will always have the past, and then in here we have the future. So now and in the future. So the time cards. My dad used to work at companies that had the time cards, and that at this point in time was like a top-notch technology. So this is something that we fortunately don't have anymore, and I'm very happy that also the electronic systems of monitoring the time that we work is also going away. So we are moving away from the external monitoring of our working time. We, in IT at least, are professionals, and we manage our own time. We are able to be measured by the tasks that we promise to deliver, and then if we deliver the tasks on time and our average working time is roughly what we are contracted to do, we don't have any problems in the workplace. Of course, it's a bit different in different industries, so the shops have opening hours, the factories have shifts, but for us in IT, I feel that this is a privilege, that we can have this flexible working time. So we will be able also in the future to start early in order to finish early and go for a run. We will be able to go see a doctor if a child is sick. We will be able to carve out some time to do the groceries in the middle of the day, right? So there are also costs associated with it, Because if the dimensioning of the time that is necessary for us to do our job is not accurate, then we run into the risk of over hours, and maybe the over hours are not always fairly compensated. So that's a risk if a system is immature, if a transformation is halfway through, but not yet done, right? But this is at least the first aspect of the change that is happening in our lives. And moving forward, we don't go to the offices every day. At least many of us don't do it. This is a global trend. I was doing some studies, so I'm not telling just for myself. I have moved to Gdańsk, to my virtual home office 7 years ago now, and I'm very happy with it. But there are many people who do other things with the flexible workplace. I am not the one who invented the term workation, but I heard that workation is a very cool thing to do, and I can imagine many amazing places that I could go to check it out. But I think maybe I will do it once the kids are a bit older. This is another aspect of the change that is happening right now. Then another one. So I'm giving you the female perspective, maybe unsurprisingly, but this is something that was believed a choice that we have to make, that you either are a good employee or you are a devoted parent. So this is not the case anymore, and it does not only relate to our life as parents. It also can be our athletic attitude. It can be our life as a party person. It can be our life as a board game fan. So we are now allowed to have multidimensional lives, and we can carve out a lot of time from our professional lives to do our hobbies or anything that we want to do with it. So this preconception that you are either a good parent or a good employee is also gone, or hopefully gone, and in most companies. Let's say that. All the things that I'm saying here, guys, they are trends. They are something that we see is happening. So depending on an organization, they may be either already pretty mature, or they can be just in progress or happening. But this is something that is happening globally, and I don't believe we will see this turning back. Moving forward. So, do you know this guy? I think in Poland we have this saying, like Janusze biznesu. So that's Janusz. So if any of you guys is by coincidence called by this name, I apologize. But this is all about the micromanagement. It's all about the will to control every aspect of my organization's life. It's also about not trusting one's employees. It's also about trying to save every penny. So not paying the over hours is something that the Janusz biznesu would do, right? So this figure here, I have not had much interactions with those guys, but I had some of it, and I am so happy that this is going away. So if you look here, the leadership that I'm referring to, one of the colleagues told me that maybe we should refer to as coaching, but this is two-dimensional. This is first about our relationships to our managers, our bosses. So what I like to see is I like to see my manager as my support. I like to see my manager as my coach, as my peer person to bounce off ideas. I would like my manager to trust me, to empower me, and I would like my leader to challenge me as well, right? So the feedback, the receiving feedback is also a tough art, but let's say that the relationship between the manager and the employee is changing. But there's the the second aspect to it. The second dimension of leadership is that leadership is not about the hierarchy. It's not about the management ladder. It's about all of us being able to be leaders. So leadership is about challenging colleagues if they are at the wrong. It's also about approaching somebody who's 2 steps up in your hierarchy if you feel that the company's strategy is wrong, or if a process is not properly working, or that the process is not dimensioned correctly, right? So the leadership is now a trait of a person. It's not something that we would consider only for managers. So the most junior person in a company can also demonstrate leadership skills. And then the final aspect in my first part of this talk is about the change that we see in the way we work. So for my parents, it has been pretty natural to work for decades for the same employee, or even for a lifetime. And in Nokia, we also have many people who have been with the company for decades. So they have spent most of their life working for Nokia, and this is amazing. But right now, what is expected is the lifelong learning, the constant change. So the faster learning of new skills, the reskilling, the change of a career. So I may look like a bad example of this change that I'm describing here, because what I showed you beforehand is how I have worked for the many years in the same company, now called Nokia. But the fact is that I have changed my career many times. So I have started as a software developer, even though many of you would say that it's not true. So maybe I was a lousy software developer, or maybe some of you would say that MATLAB is not even a programming language and would laugh me off. So maybe I erase this one. But then I have been a radio research engineer. I was filing patents. That was a very rewarding job, and I'm not saying financially. It was very rewarding to see my work being used in the radios all over the world. But then I was a team leader. Then I was a content developer. I have grown different skill sets over the course of my career, and what's happening at the best companies is that they retain employees, they keep their good employees with them by allowing them to change jobs within the company in an easy way. So the internal job market is something that many IT firms develop within their organization, so that they don't lose talent that wants to do something else and would jump to a competitor or a different industry. So all these skills that I have described and all the changes that are happening in the workplace, they all constitute something that can be described as the employee experience. And one of the things that I would like you to encourage is that you all take into account the employee experience in your choice of your employer now and in the future as something that is just as important as the financial package, right? Of course, as soon as you earn enough to make a living or do the things that you want to do. Maybe you don't need to earn the extra bucks. Maybe you would rather go for an employer that allows you to have this fulfilling life and a good employee experience. So we are in the now. So what's next? What's like around the corner? So I would start this part with what's around the corner, with a bit of tapping into the technology. That's my only technology part for today. And what I will do, I will describe a bit of the 2030 technology vision, and I'm doing this in order to give us also some perspective on the substance that we will be working with. So many of you guys are in the software development, so this means that also the topics or the substance that you are working on is important for your work. We have seen already very cool presentations today on the LTE network on the moon, on building the software and the new constraints that are necessary if we are building a software that actually will be deployed on the moon. So this is one of the aspects of what we are seeing here. So what's here? I have attached the link there. So there's a technology vision 2030. I think most of the big films with this sort of ambitious future outlook have the technology vision 2030. I think, well, at least Gdańsk also has the technology vision 2030. I guess Wrocław also has a 2030 vision for itself. That's just strategic planning. But what we did in Nokia is we have launched a few years ago this multi-dimensional teams. So the teams that are constituting of professionals from different domains, and they looked at the different streams or verticals, if you will. So this covered both the social changes, the geopolitics, the environmental aspects. It also covered the technology changes, the device changes, okay, maybe the metaverse, maybe all the XR applications, the cybersecurity or quantum. So all the things that we see will be impacting the technology in 10 years from now or from then are covered in the vision. So if you look in here, you would see the circles. So the human world, I think that's pretty self-explanatory. That's us. So this is humans with all our culture, all ambition, or values, all the things that make us a human. The physical world also, that's pretty obvious. So that's both the nature and the technology, the human-created physical objects. And then the digital world is all the data that we have created. It's both the entertainment, it's the work, it's the business, all the digital stuff that we have created so far and that we continue to create every day. So the interactions between these worlds, they define the world of the future. So the human world is and will be interacting with the digital world. We are building the programs, we are digitalizing things, and at the same time we are consuming the digital world. We are watching our Netflix movies, but then we are also doing some work. Then the digital and physical world, they also have the similar interactions. So these are like actuators. This is the sensors and the reading from the sensors into the digital world. All the foundation of the future digital life. And this all connected with a network is what will constitute this technology vision for the future. You have the headline here below. This is about extending the scope of human possibilities. So this is really very high level. But what this means in practice, and this is also something that will define the what. So what we will see coming in the next few years for us IT professionals is maybe shown in the picture here. I will show a bit simplified view in a second, but these are just some characteristics of a network that are happening right now, that will continue to happen over the next few years. So you can see here the network performance aspects. You can see there some new network capabilities like the sensing and positioning. So this is not that mature yet or not hitting the mass market. Same actually with all the metaverse and XR. So we see that this is somehow starting, but it's not hitting the mass market as fast as we have expected maybe a few years ago. But still, this is coming. So we will need all the capabilities of the network, and also these things is something that will be the substance of our work in the years to come. So maybe some of us will be working on the low latency networks, maybe some of us will be working on the non-terrestrial networks and so forth. So this simplified view that I promised is here. So the topical part is the green one. So you can see here the non-terrestrial networks, NTN, and then you have the LEO, GEO, MEO. So that's all about the orbit on which we are putting the satellites that we are using for communications. But then we have all the breadth of networks that we have already now. So we have the wide area or the small cells, all those. But then what also will come into this basket is the decentralized networking. So maybe new mechanisms of building and new mechanisms of the sharing economy in the connectivity. So all these things constitute the network of networks. Then the APIs. This is, I think, something that many of you guys would have much more to say than I have. And then we expect those APIs to become more simple. We also expect that we will have a more streamlined or standardized adoption of the APIs, and then also we will make the programming of the network easier through the artificial intelligence and machine learning. And then the extreme performance networks. So the extreme performance means that the networks need some characteristics that are maybe very specialized, very narrow, like the low latency or low jitter, something that is very important for industrial applications maybe. But then it's not something that we would deploy on a wide area network, and it's not even possible to be achieved on the wide area or non-terrestrial network because of the delays, right? So the specialized networks, they can be designed, they can be deployed, but they can only be very localized, right? So all those things is something that you guys have a chance to work on in 5 years from now, maybe. So this is all about the what, so the substance of what we will do in IT in a few years from now. But then back maybe to the how, because what I also did, I looked into the industry predictions for the next few years, and then the future of work trends. I think one of the best articles I have read is from a guy named Bernard Marr, and this was with Forbes. And Bernard has analyzed the different trends for next year, but also years to come. There are 8 of them. Some of them we have actually covered already in my first part, like the decentralized workplace, right? So those aspects we have already covered. Some of the aspects maybe I will not cover in this speech anymore, but that's just because then you have a chance to maybe read Bernard's article yourself. But then there are 2 of those that I want to dive into a bit. Then the Gen AI. I think we have had at least a few talks already today on the Gen AI, and I would guess that many of you have already experienced yourself, not just with the ChatGPT. I think when we had the ChatGPT boom, almost everybody has tried to form an opinion of ourselves, what the ChatGPT can do. But I would guess that many of you have also your own experience in programming with Copilot, maybe. But let's go. So whatever we say about the Gen AI, it has already pretty significant impact on many industries. It's not just the software development, it's also like pharmacy or legal or creative. I think the the customer service we also maybe know by ourselves, because we are faced with a chatbot instead of a person if we want to complain about a service. But then the applications are very broad, and then one that I want to focus on is in programming. I will now show you a few statistics, maybe a bit provocative. This is coming from McKinsey, so let's see how you guys react. So McKinsey has analyzed the gains that are possible with the Gen AI in software development. The first chart here is the financial impact on an industry as a whole. That's ranging from 20 to 45%, and this is like annual savings that the companies can achieve with Gen AI. And then the 56% is the speed boost that McKinsey is reporting. I have my own opinion about it, and my opinion is that this probably is a corner case. So this must be a corner case, which means that this is a very simple or repetitive code, like completing a loop or something. I wouldn't see that this high gain is something that is achievable on a broader code base in a consistent manner. But at least this is what McKinsey is reporting in their analysis, and this report I'm also linking in the backup slide for my speech here. And in this report, they analyze multiple industries. I'm only snipping here the results for the software engineering. However, this is exactly my point. So the Gen AI in programming, so like the Copilot, it can be helpful, but it will not replace the proper design. It will not replace the complex logic, the human factor. We need to have the human overlooking all the work, and actually it is I have at least talked with a few colleagues who say that the work with a Copilot is very, very tiresome, so that the AI, the generative AI, can create snippets of code, but the quality of the code is so uneven that it's just not possible to rely on. So there is very high potential for savings, but what's important is that we need to find the right use case. We need to find the right environment to create it. So what the generative AI is, and this is my opinion here, is that it's but a tool. So this is something that we need to know how to use. We need to find the proper circumstances to use it. We need to learn how to properly and accurately prompt the machinery to generate what we want it to generate. And actually, I have talked to some colleagues who have said that actually learning and creating the proper prompt for the AI machinery is sometimes maybe even just as time-consuming as generating the code itself. So I would say that we should not underestimate the generative AI in programming, because it has tremendous potential of improving the lives of programmers, because it can offload the dull and mundane tasks from people. It can save time. It can keep them more, allow them to spend more time in the flow. But what is essential is that we learn where not to use it. We learn how to control it. Maybe there will be a new category of jobs, like AI babysitters among the programmers, right? That's also a possible outcome, because what may happen is that the generative AI will do some of the programming tasks, but it will also generate new jobs or a different category of jobs for us programmers to increase the efficiency and manage the whole process. So this is one of the skills that we will need to develop for the future. So, and actually, not just in software development. So what I read in some reports and what I agree with is that the knowledge how the LLMs work, the knowledge how to prompt them, how to oversee them, how to generate value with AI without pushing it to hallucinate, is something that will be a skill of the future. And in many industries, so not just the software developers, right? So people from many, many industries will need to learn how to work hand in hand with the AI machinery. So that's one thing that we can predict for the future. That's one part of the skill set. And this takes me to my next part of the speech. This is about the skill set changes in the workplace. So first, I have already said this, the data and AI literacy will be needed in many industries. So people who have worked in an industry for a very long time, they are faced with a need to learn something very new and maybe disruptive for how they perceived the world for a long period of time. Then the soft skills still on the rise. And then, I think you will see this in a moment, the diverse and distributed environment, something that I mentioned already, that we are moving away from this 8 to 4 fixed working day, everybody at their desk environment. And then with that, maybe the teams will not meet just as frequency. How would we brainstorm? How would we do the design thinking? How would we, in a digital environment, co-create? This is we do this now. I do this all the time because I'm located in Gdańsk, and nobody else from my company is located there. Well, my husband is, but we don't work together. But what happens is that we need to learn how in this very distributed environment still stay productive and creative. So that's one set of skills that will also be needed for the future. So what I have shown until now is a set of, if you will, drivers for what comes in the future. And then in the summary now I would show the skill set that is foreseen. So in the skill set, I have used the World Economic Forum report. It's a very long one, but a very good one. So they interviewed 800 something companies that span across multiple industries and multiple geographies, I think. In total, over 11 million workers in those companies. They didn't interview all of them. They interviewed their leaders, but that's basically the base that the companies cover. So there is this set of skills, and in here it's not very readable. I'm going to a more readable view in a second, but I very much encourage you to read the report because the report is very detailed. It provides a breakdown by industry. It provides a breakdown by the geographies, by the skill sets. It also maps the skill sets to different categories. So there is quite a few things to learn, and it's open. So that's always a plus if a report is open. So if we look at the top 10, just top 10, in here you have first. Let's start with the technology related. That's 2 of those, right? So there's the AI, there's the design and UI. If I looked at the next 10, also programming was there, the security was there. The design for security is also something that is on the rise. Then the next thing that was there was also the talent acquisition. So meaning that it is foreseen that it will not be as easy to find the good employees or the ones that are fitting your business. Then, next up, this is what I already told you about. So this is my mapping for the human factor that is needed to complement the AI. So we will need to control it. We will need to think critically about what the AI creates. We will need to come up with our own new solutions that go beyond the learning patterns from the past or from what the AI is learning. And then what's the last category? I will show you my mapping, and then you tell me if you agree. So my mapping for the last category is leading others and self in a distributed environment. So that's how I see it. So my understanding is that those blue dots, and if you look, they constitute half of the first 10, is about how we are able to overcome the fact that we are maybe not in the same place, that maybe that maybe it's just me and my computer and my task, so nobody overseeing whether I'm actually working. So I need to have the self-drive. I need to motivate myself to deliver, right? Then I am in a different location than my peers. Then we are not able to meet and co-create, right? So all of those things, they pretty much constitute to this top 10, right? But then what happens now is I am at an end of my speech, and I am 10 minutes early. And I think this is because I spoke so fast. So my final words is, first, we should all gear up for a constant change. This is something that we have seen also in the past, but now it's accelerating. And it's accelerating because of the computing power that we now have, and we will continue to see the increase of the computing power via the advances in silicon technologies. So the more computing power there is, the more advanced algorithms we can create, and then the bigger challenge would be to keep up with those, right? So I think the next years will be pretty interesting for us. So we need to mind the skills. We need to think what will make us relevant in the market in the years to come. And it's not just the skills that we have right now. It's also the new skills. It's also the skills that will come in the future, or maybe we don't know them yet. But then we also need to choose our employer by the employee experience. This is something that I said before, and I cannot emphasize this enough. If we only focus on work, we are headed for burnout, and this is not good for us, and it's not good for our employer either. So when choosing an employer, we should all mind also the whole employee package, the experience of working at the company. So let's ditch the ones who are micromanaging us. Let's ditch the ones who are not allowing us to have light outside of the work. Let's be smart in choosing where we work. That's it. Thank you. Thanks, guys.
Thank you very much for a really interesting and inspiring presentation. So now it's time for questions and answers. So if you have any question, then please raise your hand. Okay.
Hi. Nice talk, thank you. At the beginning of the talk, you mentioned how we experience this remote work and we're not going back. But I've noticed a wave, especially in the last half a year, of companies kind of returning and mandating a return to office, especially bigger companies. And even companies that see the benefits of remote work, a lot of them are just scared, and they do this kind of half-half, they call it hybrid mode, where they still mandate that you have to spend some days of the week in the office. And it seems kind of hard for me to believe that we will ever return to COVID levels, because it was literally legally mandated. And for me personally, it feels like the wave is not even over yet, that it's going to worsen, so to speak. And I had two questions relating to this. Have you noticed this wave? And what are your thoughts? Do you think that we're already past the point where it kind of got the worst it can be, and now more companies are going to embrace remote work? Or do you think that we're going to stabilize and it's just going to stay about here? And my second question related to that is, for companies that do choose a full return to office, and maybe to a smaller extent for the hybrid companies, do you believe they're making a mistake? Or do you think it's just, either way works? Thank you.
Cool question, and it addresses something that maybe I didn't manage to pass clearly enough. So my belief is that at least in IT, there is or there shouldn't be no comeback to full office work. Everybody in the office Monday to Friday. This, I believe, should be gone in our industry. That's my belief. I think that the wave of hybrid work with a few days in the office, coordinated, right? Best coordinated, because why are we doing this? We are doing this to allow the teams to meet or to have the whiteboard discussions. I think this makes sense. What I'm claiming is that it is not a good idea to pull the plug completely on the remote work. And I believe there is no going back to pulling the plug completely on the remote work in IT, simply because the employees have already experienced that it's possible, that they are still productive while working remotely. But then, guys, I may live in a bubble. Well, I'm sure that I live in a bubble because I'm working remotely from Gdańsk for 7 years. But I'm talking to people, and as much as I see that in many industries this is not a norm, it is still a norm to be made to work from the office for most of the days. It is maybe seen as a benefit if then they can have Fridays from home, right? Or Mondays, if you will. But my belief is that this hybrid work with a coordinated days where the team would meet in the office is something that we would converge on for the years to come for most teams. But I welcome, we have the mic still, so I welcome if any of you has a different view. I'm happy to learn. Any other questions? Ha! That will be a tough one, gearing up.
I have a comment embedded in a question. Don't you think? So we switched to remote operation and everything goes nice. Don't you think that it goes nice because it is a kind of inertia? The people knew each other very well for years. They've been working together for years. So then when they switch to remote operation, it works fine. But when it comes to a situation when someone new is joining the company, it is much more difficult and inefficient.
Yes.
And maybe this is the problem.
Yes, you are 100% right. So the companies are making savings on the real estate, maybe with the remote work. So they should invest in the ability for the people to meet every now and then, right? So even if people are working remotely, if this is economically possible for a company, they should organize the gatherings a few times a year so that people actually meet each other and they learn to trust each other. And actually, this is why we had so many of these blue dots in the last screen, because working in this very distributed environment without meeting your peers is very, very difficult. So this is a challenge that we will need to solve. You're completely right. 1, 2. 2 more. Now I know why I saved time.
Thank you for your speech. I noticed that on top 10, in which you showed us, there was a leadership quite high, on 4th place, as I recall. Yeah, so 4th place, and empathy, which is quite close or usually goes together with good leadership, is on place 10. It is a surprise for me. Do you, in your opinion, the tendency for empathy will be to go higher in this top 10? To close the gap with leadership?
I have no clue. I have not thought about this way. So somehow I would have assumed, if somebody asked me this question, I would have chosen both, but if I was given a choice, I would have chosen leadership, because my belief is that leadership sort of includes empathy as well, right? So maybe breaking out empathy to a separate category is something that I would question. Yeah. Kuba.
So you mentioned that right now you're collecting technical data and translating it for business purposes. Aren't you afraid that large language models will take over your job soon?
Yeah, that's something that everybody is afraid of, but that's also something that people were always afraid of, right? So they were people going on strike when the Industrial Revolution was happening, and I think there's no stopping of the progress. My belief is that we will have a tough period. So some of the work that we are doing will be taken over by the LLMs, but then maybe this will be the worst part, the one that we don't necessarily want to do, and maybe there will be other more interesting jobs come up that somehow spring from the fact that we are having this AI revolution, if you will. Of course, I cannot predict it. I'm not even the expert in AI, but this is somehow how I would hope to see the future of the world.
Sure, thanks.
One more.
Yeah, so I have this maybe provocative question. Why shall I choose employer when I can be my own boss and become freelancer?
Sure.
From the first part of your presentation, the conditions are virtually the same in both cases.
Yeah, sure, you can do that. It is all about which level of security do you need to keep, and in order to trade for freedom. So it's the trade-off between the financial security and the freedom of choosing your projects, right? But I agree. So if we are top professionals, and we are, then we can go freelance, and then we can maybe acknowledge the fact that maybe we will be without a project for a short period of time, but then we will find another one, and then we will thrive. So, but actually, when you are a freelancer, you're back to square one. You are again choosing your project also based on the relationship with the company you're working for, right? So if this is a company that's micromanaging you, or if this is a company that's changing the requirements all the time, you would not work for them again. So this is back to the employee experience as well, right? But then you get to choose it yourself, so you're even more in charge. Yeah. One more.
Thanks. So my question is a little bit related to that number 4 and number 10 distance between those points on the slide. on what is the way to arrange this list, because I see that AI and big data is number 3, but on the previous slide, AI and big data was a little bit further down the line, I think. Yeah, AI and big data is now on 7th position.
Yeah, I think the screenshot that I took here was regional and not global. So what happened now is you caught me on data inconsistency. Thank you very much.
Okay. That was just great.
Well done. Okay. Thanks, guys.
Thank you very much.
It was a pleasure talking to you.
Okay, so now we will have another speech at 4:15, so in around 10 minutes. And before the next speech, I will Okay, so please take your seats. Don't sit on the stairs because it's against occupational health and safety rules. So please take your seats and sit. And as I said before the presentation, I will have some interesting facts about Venus, so the planet. And those facts were generated by ChatGPT. So the 10 first facts. Venus is a second planet from the Sun, and it's orbiting between Mercury and Earth. It has similar size to Earth. Venus is often called Earth's sister planet because it is similar in size and composition, and it has a diameter of about 12,000 kilometers, which is very close to ours diameter. It rotates backward. So its axis is in the opposite, moves in the opposite direction to most planets in our solar system, including Earth. This means that if we were standing on the surface of Venus, then we would see the sunrise in the west and set in the east. So this is interesting. It has thick atmosphere. It has a dense and unfortunately toxic atmosphere, which is composed mainly of carbon dioxide with clouds of sulfuric acid. Yes, please take your seats. Yes, and another fact is that this thick atmosphere traps heat, which leads to an extreme greenhouse effect and making Venus the hottest planet in our solar system. Yes, and also another fact, fifth one, is extreme temperatures. So the surface is incredibly high, reaching about 467 degrees Celsius. And this is hotter than the surface of Mercury, even though Venus is farther from the Sun. Venus has no moons or rings. Unlike many other planets in our solar system, Venus doesn't have any moons or rings. It has retrograde rotation, so Venus not only rotates backward on its axis, but it also rotates very slowly. It takes about 243 Earth days for Venus to complete one rotation, while it only takes about 225 Earth days to orbit the Sun. Another fact is that about volcanic activity. It means that Venus has many volcanic features, including large volcanic plains and thousands of volcanoes. And some scientists believe that Venus might still be volcanically active. And the last two facts are that it has lengthy day-night cycle. A day on Venus, so one rotation on its axis, is longer than a year on Venus, one orbit around the Sun. A day on Venus lasts about 170 Earth days, while a year is only about 225 Earth days. And the last one probably is the most known, that it is named after the Roman goddess of love. And Venus was the goddess of love and beauty, and it is sometimes referred to as the evening star when it appears in the western sky after sunset, and the morning star when it appears in the eastern sky before sunrise. I hope that those facts were generated correctly, so that the ChatGPT was correct. You can double check it. And now, allow me to introduce our next speaker, Michał Węgrzyn. Michał is a Scrum Master with psychological background. His agile journey started in a healthcare software house. Now, he's working in Nokia for 2 years. In the company, you can find him conducting trainings, facilitating Scrum Masters community of practice, or playing poker, planning poker. What developer and psychologist have in common? It depends. Michał, the stage is yours.
Whoa. Well, that was a lovely introduction, and indeed, that's me, Michał. I'm a Scrum Master, and today I'm going to talk a little bit about our minds and why sometimes common sense doesn't make sense. So let me start with a dad joke, so please fasten your seatbelts because it's going to be a crazy ride. That was a dad joke. Thank you. Yeah, if there's anything that I want you to remember from today's talk, there'll be 3 key messages. The first one, the way how our brain is wired, it's a result of thousands of years of evolution. And it was shaped in a completely different environment for different challenges where surviving strategies were promoted. Then, we might feel good with the wrong answers, and those are called cognitive biases. And by the end, we can't change the way how our mind, how our brain process the informations, but we can reflect on that and therefore make better decisions. So I said, let me start with a dad joke, but indeed now is the time to truly start this talk. So the question for you, and feel free to say it out loud. Do you want to play a game? Yeah, very well. Hi there. Very well. The rules are pretty simple. I just want you to answer to the question as soon as it's possible. It's a short riddle. It comes from the American context. It's going to be about baseball. So, you ready? Yeah, that's cool, because me too. So, a bat and a ball cost $1.10 in total. The bat costs $1 more than the ball. And now the question, how much does the ball cost? Oh, come on, you knew it before. I knew it. Why I knew it? Because you have a great abilities for critical and logical thinking. That's your job. But yes, that's the correct answer. Usually, the people are answering 10 cents. Why? Because it's intuitive answer. It's the first answer that shows up in our minds. So you know the math behind that. So $1.05 is exactly $1 more than 5 cents. That's brilliant. So now let's have a look on something else. The same problem from different angle. Like we already here got like great audience that know the answers, but roughly 30% of undergraduates in United States from different universities, they give the right answer only in 30%. I mean, 30% of them gives the right answer. So then there is a question, like Backstreet Boys loves to ask this question, tell me why. So let's start with an explanation from a biological point of view. So let's start with a lovely device. That's device. It's called central nervous system, or just simple brain. It's a great example of evolution, where we can find the oldest part of the brain in here, and then the further we go with evolution, the newest are here. So it processes a lot of information over 24 hours. It is estimated that there are around 70,000 thoughts a day. You might be curious how they measure that. Of course, they haven't asked like, hey, how many thoughts you have per day? Because it doesn't work like that. They were just checking the neural impulses that are traveling through our brain. So yes, that's a lot to do. Like I mentioned, this part of the brain, the newest one, is responsible for the higher cognitive processes, for our understanding of difficult, complex problems, for logical thinking and critical thinking. Also, for controlling ourselves, for controlling our impulses. You might be curious, I believe, you might be curious how much energy it consumes. The answer is simple, a lot, but how much indeed? So the brain itself weighs about 1/50 of the whole body weight, but it consumes 1/5 of overall energy. So as you can imagine, every activity that will help us to reduce this number of calories that are consumed, it's highly valuable. So we have 70,000 thoughts over the day. We are constantly processing if we are safe. Yeah, that's a fun fact. The brain is not created to think. It's created, it's developed to help us to survive. And it's the main goal. Thinking is just a feature of the brain. So let's see how this thinking process looks like. And I'm going to use for the explanation dual thinking theory or dual system thinking. It depends. There are a couple of theories that describes that. As you know, that it's a 5 cents. Perhaps you also know what's the part of dual thinking theory. So don't be surprised. There are two systems. System one, it's mostly unconscious. So the thoughts are simply traveling through our minds, perceiving the reality. If I see the speeding car towards me, I know I need to jump. I don't need to think about that, simply doing that. If someone asks me, hey, Michael, what's 2 + 2? I'm just giving the answer because it's 4. Ha, great. So system one is really fast. It just simply gives the answer to us. It's really intuitive. It's effortless. You don't need to think about something which you even don't know you're thinking about because system one is unconscious. But there are more difficult questions than 2 + 2. Like, for example, how much is 17 times 24? Please don't think about that now because you will stop listening to me and you will focus on that question. And indeed, that's the system 2 that is responsible for more critical and logical thinking. It also consumes much more energy, and comparing to system 1 is much slower. So on one hand, it can help us to create 5G, like here in Nokia, or can help us to send 4G to the moon. But on the other hand, it consumes a lot of energy and it's just simply slow. We need to, and now pay attention to what I'm going to say. We need to pay attention, which means the amount of attention that we have is limited. So we cannot focus on too many things from a system 2 point of view to process them. We have a tendency then to forget or to omit some other piece of information. And the best example of that situation is that meme. So when you're turning down the radio to see better, anytime I'm driving a car and my sister is sitting next to me, she's laughing at me. Oh, you did it again. You turned the radio down to see better. And indeed, I've done that on purpose because I need to reduce the amount of information for my brain to process and to better focus on the right task at that time. Very well. So we, at the moment, we have a good view. There are two systems. One is like checking all the time. When there is a need, the system 2 is activated. So we are doing well. Yes, system 2 always know when to act. Is it true? Not always, because system 2 acts as a lazy controller. So it's looking for information from system 1 that's if everything is going according to the plan and some action is required, or no, there are some, no, what I said already, sorry, once again. So if everything is all right and no actions are required, and no, there are some difficulties, system 2, we need you. So, sorry, there was a spoiler alert. You already saw the question. I hope you haven't read it, but maybe your system 2 already did. Anyway, so let's see if we can detect the violation of the process. How many of each type of animal did Moses take on the ark? Any ideas? Okay, because you know it. Yeah, but that's true. The correct answer is 0. Why? Because it wasn't Moses who built the ark and took the animals. It was Noah. So what happened here? Our system 2 was activated, indeed, and was trying to find the right answer, but for the wrong question. So what we can do with that? We need to trigger somehow the system 2 to act on the right question. So now let's have a look. There is another trigger. So how many of each type of animal did Musk, the Elon Musk, you know this guy, take on the ark? Oh, 0, because he haven't built any. Unless you know about any ark made by Musk, then let me know, please. Right. So what's then? It's our ability to reflect that there is an intuitive answer that arises, and it arises all the time. Those of you who said it's a 5 cents, at the beginning there is an answer that it says it's a 10 cents, but then we add another layer of thinking to process the question. And the cognitive reflection test, it's a really good tool to check our ability to reflect on the task, to detect defects in the thinking and address it in a correct manner. So you might be curious, what is that test about? Is it really complicated? Are there any special devices to check our ability to think? So the test itself is really easy. There are 3 questions. You already know one, because the first question I asked you at the beginning, I mean the second question. The first one was about if you want to play a game. So the riddle I asked you is exactly one item from that test. There are 2 more, and that's it. And it checks our ability to detect inconsistency and in thinking. So you might say, hey mate, but you showed us. Now we can't take this test any longer because we know the answers. It's not necessarily true. The test is robust to multiple exposures, which means if you don't have a reflection, the cognitive reflection, even after, if you make the test after a long time, you won't notice that there is something wrong with an answer, and you will say anyway, it's a 10 cents. It's a 10 cents for the ball. I was conducting once an experiment, a short survey. We were checking, the effect of sunk cost effect when we have a tendency to continue unprofitable actions, and we wanted to check if there is any connection between cognitive reflection test and the sunk cost effect. That was around 3 years ago, and after the survey was spread all around the people, they started to texting me. Hey, Michał, but there is a question from a TV series, from Ślepnąc od świateł. The Polish audience may know that. And that was exactly the same question, so I knew how to answer. So that's okay, because the prior belief helped you to detect inconsistency in thinking. So it's all right. I'm glad that you saw that, because it means you are not rely too much on your system 2, on your system 1, and you activated some critical thinking. Because you reflect, you know that from somewhere. So let's have a look how prior beliefs can help us to detect inconsistency in thinking. It's a pretty fresh, 2014 was already 9 years ago. So it's not that fresh, but it was a short experiment on prior beliefs and our ability to detect inconsistencies. As you can see, it's the modified version of a bat and a ball problem. Again, we have a $190,000 and $100,000. So the intuitive answer arises. It's a 90,000, and the prior beliefs that researchers use in that case is our belief about which cars are expensive, which category of cars are expensive and luxurious, and which are known as being more like a cheap city cars, etc. So the differences between those two. In that manner, both of Rolls-Royce and the Ferrari, they are luxurious, expensive cars. So when you give the answer, it's a 90,000 for Ferrari in that particular case, you see just a 10,000 difference between them, and it's like, okay, they are both expensive. I don't care. It's all right. But then let's switch it a little bit, and we have a Ferrari and we have a Ford. Ford K, it's a lovely city car. Then again, the intuitive answer arises. It's a 90,000. Only 10,000 difference between a Ferrari, this Italian luxury car, a sport car, and just a little one city car. How come? So then you can add some additional thinking processes and reflect. Oh, indeed, it's only 45,000 for Ford K. So that can help us to detect the inconsistencies. You might be curious, okay, Michał, but you already said about that. There are 2 experiments. Are there any difference in the results? And yet there are some. So in the first case, with the Rolls-Royce and the Ferrari, there was only 14% of the correct answers. In that case, we got 25%. It's not a big thing, but it's honest work. So, people got better with that. Yeah, lovely. So what else can help us, what can help system 1 to detect some inconsistencies or the system 2 is needed. So it's in cognitive ease. So the level of easiness that we can perceive the informations from a book, from all around, from the talks like this. If I'm saying something wrong, then you must focus more, and you are going to cognitive strain, and you must be, more engaged. So you are more critical. So it's better for me to be clear and easygoing. Anyway, cognitive ease, it's a spectrum from easy to strain. So when we are in a cognitive ease mode, we are perceiving things as just easygoing, don't need to focus. So when you check in TikTok, it's like, funny, good, and you don't need to think much. But when you start reading a piece of documentation, the old code from the repository, you're like, what's going on here? You need to focus, and it's an unpleasant feeling, You are trying to avoid that. You start to procrastinate. So yes, we have a tendency to look for the easier things. And it's a great indicator for System 1 to engage System 2. If things like difficult things happen, then we must act. I mean, this part of brain of mind. Very well. So what may influence as perceiving something as easy one? So those are positive feelings. But before I'll dive really deeper into the positive feelings, at first we need to align with the feelings itself, with the emotions. So emotions, feelings, they are the messengers for our mind, for our bodies, for ourselves, that everything is fine when we face the positive emotions. Oh, I'm feeling good. It means my needs are fulfilled. My belly is happy. In Italian, there will be la mia pancina è felice. And, life is brilliant. You don't need to focus because there are no danger in an environment. When we face some difficult emotions, which are also known as negative emotions, then there is an information, oh, I need to act. I need to act somehow to fulfill my needs. I'm hungry. I need to eat, for example. So when we perceive, when we feel the positive emotions, we are also in so there is no challenge to face. I can calm down. So when I'm going to the shop, I'm really happy because I met such a beautiful girl already. Oh, and this jacket cost, I don't know the context. From which countries are you? Because so we have a Poland. Any other countries? I mean, I'm talking about the currency. Okay, doesn't matter. Yeah. So just for you to know, let's say 4,000 zloty for a jacket. It's an expensive jacket already. All right. So that's the case, and you are already feeling positive, and you see that, and it's like, okay, I'm good with that. I can buy it. I don't need to involve more thinking processes. So because of the positive feelings, you perceive it as a easy thing. If you will be in a negative mode, mood, most likely you will say like, how come 4,000 for a jacket? That's already expensive. People are dying. It's unfair to pay so much for that. So yes, critical thinking help us to involve. Negative feelings help us to involve critical thinking because it's needed to survive. And as I said at the beginning, the brain, the mind is not here to think, it's here to help us survive. So there is one indicator that can influence the cognitive ease. There is another thing, which is mere exposure effect. So the more we see something, the more positive we feel with that. Simple as that, truly. So let me ask you another question. What do you think about those words? Are they positive, negative? Yeah, very well. That's the right answer. Because they don't have any meaning. Those words doesn't exist. I mean, they are printed here. I mean, they're here, but they have no meaning. They were created on purpose. They're supposed to sound like Turkish, something like that, but there is no meaning behind them. And why I'm telling you about the words? Because they were used in an experiment made by Robert Zions. Robert Zions is also the author of Mere Exposure Effect. Just in case, Robert Zions is an American psychologist. And it's not Zions by O, it's Zions by O-N. If you want to check it in the future. So what is the experiment about? So Robert Zions bought a series of advertisements in a local newspaper. On the front page there was a frame, and he was printing, I mean not him, but the newspaper, they were printing some of those words. Some of the words were printed almost every day, while the other like once in a while. Some of them not printed at all. As you can imagine, people around were curious, like, hey, what's this advertisement about? They said the author wants to be anonymous. Okay, fair enough. Questions no more. After a while, he asked his students to come to the university, and said, hey, I got the survey for you, okay? Please rank the words from the most positive to the less positive. Is it okay for you? They said, okay, it's positive. So so they ranked the words from the most positive to the lower positive, to the less positive. And believe me or not, remember that these words has no meaning. The words that were printed the most were assessed as the positive ones. Lovely, ain't it? It's enough to see. You don't need to understand. And why? These guys know the answer. Because they don't know how to talk, but they need to survive in a challenging environment. Everything could kill you. It might be an animal, it might be a plant. So better be ready for a death. So you are approaching everything with cautious. But if after several of encounters, this animal haven't ate me, I'm still alive, it means it's good. So I can approach very well. So our basic approach is to avoid, to be skeptical, and then the more we see something, the safer we feel with that. So the positive emotion arises. Everything is perfect. It works not only for human, but also for animals. But then I realized we are animals as well. So it works for all of us. Lovely. What else can affect our feeling, our perceiving of cognitive ease? I mean, that we feel ease with the things that we perceive. It's a graphic layout. So you might be curious, why those guys from UX design, they are so needed on the market? Simply because they're letting people not to think when they perceive informations. So the better they create the layout, the less chances are that people will be the people will be forced to think, and most likely they will buy the product. Simple as that. So the easier it is to perceive the information, the less chances are that we'll consciously think about them. And then, can you remember from schools those xerocopies from your teachers when there were the exams and you had to, put a lot of effort into understanding? Perhaps they helped our grades. Of course, in the case when we prepared for the exam, but forcing our attention, our cognitive effort to understand what is written down here helps us as well to detect our own mistakes. So most likely, in some percentage, we got better grades. Don't you believe me? I have a proof for that. So again, about the cognitive reflection test and a student. So there were 40 students. They were given the cognitive reflection test on a 2 version. One was really nicely printed. Yeah, so the font size was easy to read. The color of the font was black, so the contrast, everything, just a regular thing. While the other group received it on this Mr. Incredible, so the font was slightly smaller, still possible to read. It was smaller and the color was grayish-like. What were the results? So from the first group, easy to read, 95% of all 20 students made at least one mistake. From the other group, the xerocopy group, let's call them, only 65%, 65 is somewhere else, sorry. 35% made at least one mistake. So most likely it helped. But of course, we need some further investigation. Good. So You may think they'll be nice to control at all the time our cognitive processes. All right, there is a thought. Is it correct or not? We might try, but this will lead us to what's called ego depletion. It's a term crafted by Ron Baumeister, and he stated that we have a limited amount of willpower, of self-control. So the longer we are trying to control our actions, the more tired we are with that, and therefore, when we are tired, we have a tendency to rely more on our intuitive answers. And examples, there you are. So you already had a difficult day at work. There were a lot of meetings. You had to make a lot of not mistakes, but decisions. Decisions, that's the word. You had to make a lot of decisions. You were about to control yourself because, oh no, I can't act like unprofessional, so I'll be, like ready for everything. So chances are that if you are on a diet, you'll go back home and don't have any more energy to control yourself and just simply break your diet. And there is another lovely experiment on that. It was a natural experiment. No judges were injured. So it's about hungry judges. They were observed during the day. They were making the decisions if they can release the prisoners. So there were 8 of the judges, not the prisoners. The average number of positive verdicts was around 35%, and there were the breaks in the meantime, so the time when they can recharge their batteries, eat something, relax, just simply take care of them and take care of themselves. And then after the break, the number of positive results went up to 65%. Why is that so? That's important. Because by default, so the intuitive thinking here is, oh no, we can't release the prisoners. That's pretty obvious. We are looking for, we are not going to look for the reasons to release them because it's additional effort and simply because we want to keep the prisoners in a prison. So additional thinking is needed to prove that they can be released. So after the break, when they are fulfilled, they can be involved in a more critical, logical thinking. But right before the break, when they were tired, the number of the positive verdicts went to 0%. Sounds scary, isn't it? Like we need to rely on people who are hungry and they make the unlogical decisions. Luckily, it's not that bad. I found the other research from this year, and it seems the numbers shouldn't be that, apart from each other. That's at first. And they explain the results, this result, as a way how they scheduled, each cases. So the more difficult cases were scheduled at the beginning, and the easy one, that they know that the prisoners shouldn't be released, were left for the time before the break. So it's not that bad in the end. Alrighty, so what can we do with that? We already know that there are 2 systems that we perceive something as easy on some unconscious, on a subconscious reasons. It doesn't need to be easy. In fact, it's just the way how we perceive it. What's more important when we talk about the cognitive reflection test, let me come back to that for a few seconds. There were around 3,000 people involved during creation of that method. And the participants were split into 2 groups, generally into 2 groups. One that made the right decisions, while the other that made all the decisions wrong. So in all the 3 questions, right answer, in all the 90, while the other group that made the right decisions, they said it was easy, but only 65% from that group stated. So we even don't know when we are wrong, when we rely too much on a system 1. So what can we do with that? It's like this optical illusion. we can't get over it. Even if I'll tell you the exact length of those two lines, our brains will still perceive it as a shorter and a longer one. So we need to simply acknowledge it. All right, it is as it is. The intuitive answers are arising in my mind. I know about that. So what's then? I need to give myself a little bit time to digest the information deeply, to spend some time on a reasoning, the proper reasoning, and also ask myself, okay, I feel good with the answer. Is it because I'm in a good mood? Is it the result of the cognitive ease? Was it printed on a lovely paper? Or, you know, good. And like that, we are going to an end of that talk. And if there is anything that I want you to remember from that talk, there'll be the three things. The first one, that the brain is a result of thousands of years of evolution, and it was shaped in a completely different environment for different challenges. The brain here is not to think, it's to help us to survive. Thinking is just the feature. Feeling good with the wrong answers are the cognitive biases. And we can't change the way how our brain works, but we can reflect on that and therefore try to make the better decisions. And by the end, that's the resources I used for preparation. And that's it. Thank you very much.
Much for our really interesting story and research-based presentation. So now it's time for questions and answers. So if you have a question, then please raise your hand.
Oh no, I'm afraid.
Yes, it won't be a hard one. Thank you.
Oh my. Go ahead.
So you just talk about that having a negative effect in a day that can be advantageous for our critical thinking. That means if I feel bad every day, that's good for my work.
If you what?
If I feel bad every day, that's good for my work, or some negative exposure.
Oh yeah, I got your point. So
I don't say that I'm depressed, but I feel bad.
Yeah.
For good reason. For good reasons, that can be a thing.
Yeah, that's a really good question. The answer is obvious. It depends. Depends on what. So the power of the negative feelings, because it's good to feel it, but it's not good when it takes over the control. So when there is the slides with the brain, sorry about that. Yeah, when there is, we can't see that here, but in somewhere around here there is the part of the brain called amygdala, responsible for perceiving emotions, for feeling emotions, and it can somehow steal your brain. So the prefrontal cortex is not thinking any longer because the mind is occupied by negative thoughts, by negative emotions. So then it's difficult. But when you are not in a positive feelings itself, there are more chances that you will be able to focus. So what I want to say, it's good to acknowledge the difficult feelings, to say, okay, I am sad, that's all right, I'm feeling that, but I can focus on a task. So you can focus deeply. When you are happy, most likely you are like a careless, so then it's also difficult to focus. I'm not sure if I answered that question enough.
Yeah, I think I understand. So it's like it's stress, so we have to know that it can help us.
Yes. So with the stress, when it's too high, because stress itself is good for us because it's mobilizes us. But when it's too high, then you are in a fight or flight mode, and you see just like that, or even like that. You're just trying to escape from a dangerous situation. When you feel the stress, you are, oh, nice, you know, sharp and easy, and then you can deal with problems. So it's there to help.
Yeah. Okay. Thank you.
You're welcome. Mamma mia.
Yeah.
Good.
Yeah, so I really like books about people behaviors and habits. One of my favorite ones are the Atomic Habits and the Power of Habit. You know them?
I don't know. And I also know that there is a book called How to Talk About the Books That You Haven't Read, but I haven't read it, so it's difficult for me to talk about that.
Okay, so the point is, in these books, they're talking about the atomic habits, yeah? So the little habits that we can change in order to change our bigger habits. So how does this connect with what you just said?
That's a great question, and indeed I was about to say that, but I forgot. So I'm really glad
You're
that you
welcome.
ask. So yeah, our brain have a tendency to optimize operations. So anytime it can, if anything could be, repeated, it can be a habit. It doesn't cost us more energy. Then it's beneficial for us for our survival. So yes, it's our natural tendency to have repeated actions. When you talk, when you ask about the habits, for example, so it's strongly rooted into how it's called, the evolution of brain, and also the way how we perceive the informations. Thank you.
So, any practical tips how to work with software developers?
Yes,
and
indeed.
use this knowledge?
Yes, great. So, as I said about the ego depletion, so if we are not feeling safe in our team, for example, if we need to control ourselves at all the time, we can't be authentic. We also reduce our capacity for deeper thinking then, because we need to allocate our mental energy into some other actions. So it's good to create good teams where you can feel right with your people, when you can be wrong, when you can give the wrong answers, because then it's then you feel all right with that. So you don't feel that much stress, which is related to your question. It is not overwhelming you. You can detect the answers, and when you are in a good team, when you just accept like, oh, we are different, I can say something wrong, you can correct me, you can detect my cognitive bias, and it's right. So the more we are like when we are in a team, we can detect ourselves the cognitive biases in our own minds. We can spend more time on the right work, not to prove that I can be the part of the group. And therefore, I want to say something about my teams. So I'm really great to be the part of 2 of my teams, because they also showed me my cognitive biases, which I'm really grateful for. Because yeah, strongly I rely on my intuitive thinking, but those great guys from both of my teams helps me a lot to detect it. So thank you guys, and thank you for the question. If it's answered that, great.
I will not ask a question, but just to share a technique that we already discussed before your presentation, so it a little bit answers both of your question. Also, if you have a time, just wait. Write one answer for the question, get off it for 10 minutes, then get back to it, read it once again, and ask yourself, is it the answer that you would like to share? Then leave it for some time, get back to it, and once again, ask yourself, if this is the real answer that you would like to give. And if all the trees are yes, then yes, this is the good answer. But if you are changing the answer, most probably you are still in the feelings, not in the facts.
I also have one question.
Oh,
because you said that
hi.
one fifth of the total energy is consumed by brain.
Yeah.
So the question is, the more we think, the more energy we consume, and we can be on a thinking diet.
That's a good point. I mean, I don't know the exact numbers, like how many calories are needed, but you may experience that when you really focus on something, when you engage system 2, the logical thinking, then more processes are needed to be created. And there are the lovely picture of that when the new neurons are trying to connect each other. So to build something new, the energy is also needed. So yes, when we are thinking about something new, when we are in a creative mode, when we trying to solve the problems, then most likely we'll consume more energy. But I can't tell you how much exactly, because I don't know the data for now. But I will check it later on and just answer myself.
Okay, thank you. Okay, is there any other question?
I can clap for you too. You are great.
Okay, so thank you very much for a really interesting presentation.
Thank you. O, dziękuję.
So please take your seats. Now, before I introduce Victor, I will share some other facts generated by ChatGPT about Venus. So it has a high atmospheric pressure, which is about 92 times that of our planets at sea level. And it is equivalent to the pressure found 900 meters underwater on Earth. And this high pressure is a result of Venus' thick atmosphere, which I mentioned before. It lacks water, so it has a very little water vapor in its atmosphere. Unlike Earth, where water is abundant, Venus has experienced a runaway greenhouse effect, causing most of its water to be lost to space. Transit phenomenon. Venus undergoes a rare astronomical event known as a transit. When it passes directly between the Earth and the Sun, transits of Venus occur in pairs separated by 8 years, with more than a century between each pair. Sparse magnetic field. Venus has a weak magnetic field compared to Earth. The lack of a strong magnetic field contributes to the stripping away of its atmosphere by the solar wind. Visible in the day and night sky. Venus is often visible to the naked eye and is one of the brightest objects in the sky. It is visible shortly after sunset or before sunrise and is often mistaken for a star. Challenges in exploration. Probing Venus has proven challenging due to its harsh conditions. The surface is hidden beneath thick clouds, making direct observation difficult. Spacecraft that have landed on Venus have only survived for a short time due to the intense heat and pressure. Rotation and orbital period resonance. Venus has a unique rotational and orbital resonance with Earth. It rotates on its axis once every 233 Earth days, and its orbital period is about 225 Earth days, creating a peculiar pattern. Geological features. Venus has diverse geological features, including vast highland regions, extensive lowlands plains, and large volcanic structures. The planet's surface is dominated by volcanic activity and is relatively young compared to other terrestrial planets. The last two facts. Venus Express mission. The European Space Agency's Venus Express mission, launched in 2005, provided valuable data about the planet's atmosphere and climate. It contributed to our understanding of Venusian weather patterns and atmospheric composition. And the last one, potential for past oceans. Some scientific theories purpose that Venus may have had oceans in its distant past. However, due to the extreme conditions on the planet's surface, any water that exists would have evaporated and been lost to space over time. Thank you, ChatGPT, for those interesting facts about Venus. Now I will move to introduce our speaker. So you can see it. I will introduce.
Okay.
So our final speaker is Viktor Kirillov. Viktor has been a regular speaker at international conferences on topics relating to C++ and is the author of a successful open source C++ testing framework. He started his career in the games and VFX industries and has progressed through compilers, databases, and distributed systems, and he is currently into blockchains and cryptocurrencies. Viktor, the stage is yours.
Thank you. Okay, so just like Venus, I had so much information which I wanted to convey, but I've taken like only 1/92th of it. So just like Venus, this presentation is really dense in terms of information, and we're already out of time. So let's get on with it. We're going to be talking about monkeys and spaghetti. I guess you didn't expect that, but we'll see later why. So as a background, last year I gave a talk at this conference titled Decentralized Identity and Content Addressing with a Blockchain at Web Scale. And what you need to know is that I still haven't started building this thing, and only a few details have changed since that presentation. It was really technical, and it's mostly irrelevant still, that presentation. And okay, so I want to add identity to the OSI model of the internet, which is constructed in different layers.
And the progression of addressing of information has been within the operating system, then within the physical network between different computers with the Internet Protocol, which is logical addressing. And now I think we need to move to the next step, which is a data network. And instead of addressing data with the Internet Protocol and DNS, we'll be addressing it by identity and a few other numbers. And so the past was all about networked computers, and the future is all about networked data structures. So a few key highlights about my solution is that it offers maximum flexibility, like you can permissionlessly extend the system any way, you can compose the data however you like. It can handle probably hundreds of billions of identities and unlimited amounts of number of data. And the key thing about it is that the social graph and the public data, they're actually shared. Apps no longer have monopoly over that data. And yes, that's a really crucial thing. So you can have a single account for all of your applications. And of course, you can have more than one account if you wish. But the key thing is that if you want to have a single aggregated identity and to tie everything to it, you can do it. And so you can end fragmentation and to have all of your online footprint in a single place if you want to do it. Of course, there are reasons if you don't want to do it. And so this is going to be a single multi-purpose network. And there's a lot more, but it's in the previous presentation. But let's see a few cool things which we can do in this architecture. Like you can follow someone just once because they might have just a single identity instead of all the different platforms. And that means you can also have multi-dimensional subscriptions. So you can follow someone, but you can unfollow them from different apps. And then you can add also different subscriptions to them for only certain types of events or tags, or you can even define custom filters. You will be able to also compose different feeds. So you're not going to get just one feed, but you can have multiple feeds and decide which subscriptions go to which feeds. And you will be able to also choose your algorithms, how content is recommended in those feeds. You will be even able to inherit the settings of someone, and these settings are not going to be just UI like colors in the UI, but you'll be able to even inherit what recommender algorithms other people are using. We'll be able to redefine the layout of panels and widgets within applications. Like if I don't want to see the Reels part in Instagram because that's it's sucking a lot of my time, I might hide it, or I might inherit the settings of someone else who has hidden it. We're going to have universal bookmarks, and we're going to be able to tune our notifications, direct message settings. It's going to be wild. But today we're going to be talking about the giant global graph of data and how we can actually give rise to something like a global brain. And so in this system, accounts are going to create events, data. And these events, they can point to each other, they can reference each other. But there's a big important distinction here, that there's a difference between the events and the state or views. And so from the same set of events, we can construct different views depending on which events we include. And even with the same set of events, we can have different views depending on the rules which we decide how to construct the state from those views. Like we might decide to count votes differently or give them certain kinds of weights. And so we can have multiple interpretations and views of the same data. And also these events, they're going to be typed data. So some of them will be text, but there will be many, many other special types of events. And anybody will be able to extend the system with new types. And for example, an edit suggestion, if you're editing something, that's going to be an edit event. And annotations are going to be a new special data type, and there can be subtypes for different types of annotations. And also, we're going to be able to query, give me all events that reference some other event. And after we get all of those events, we'll be able to filter that set however we like only events created by some other set of accounts. And so here's an example. Like in YouTube, somebody can hide the comments from their video. I mean, they can disable it. But I can take that link and I can share it on Reddit, and there people can discuss it. And to me, it just doesn't make sense to break the flow of information and to linking it that way. And in this system, you will not be able to say, I don't want comments immediately visible to this specific thing I've created. And of course, you're going to be able to filter everything. Anyway, so same data, different views. And we'll be able to define different criteria for how to construct the different views. Like I might say that I want only professors, only their identities to count in the events that I'm using to construct a view. Or only accounts which are older than 3 years, for example. Or maybe only accounts which I follow. or accounts with any type of credential or attestation tied to them. And so we'll be able to have a multi-perspectival view of the world. OK, so let's talk about argument maps. And here's a quote which I really love. I believe this topic of internet disagreement is the single most important problem of humankind. Why? Because exchanging ideas is how we make decisions in society, and how we make decisions drives everything else. If we can do that efficiently, humankind will solve every other problem more efficiently. And so, what is an argument map? Well, we have a root issue which we want to solve, and it might be broken down into sub-issues, and there might be different positions for the different issues, and different arguments for pros and cons for those. And so we can actually, when we try to define an issue, we can even define different rules how to define an issue. We can fork the rules how an issue is being defined, and we can even iterate on the types of debates when we're trying to solve a specific issue. So there are many ways to visualize structure and calculate or resolve what's the outcome of an issue. And also, every sub-issue can be a root issue of its own, in its own tree. And so here's a case study. This debate map is trying to come up with what to do with a nuclear power plant somewhere. And we have a bunch of positions. They have different aspects like environmental, economic, safety, and they have some other positions within them. And this is just one way to structure a debate about a topic. And you can expand that infinitely and go really deep. Here's another really fun one, like, is torture okay? And in this specific software, what we can see is that we can see the distribution of votes on each of the propositions. And for example, from no impact to a very high impact. And we can actually experiment with how we weight votes and try to make sense collectively of such issues. OK, so let's talk about structured data versus text. And so we'll be able to have different types of events for any kind of new signal which we want to create within this signaling ecosystem. And so with structured data, because if I express something like, I really like something, if I don't express it with text, which is really ambiguous, but with structured data, that would be aggregatable. So we'll be able to actually count how many people have expressed that specific thing. And also, another byproduct from structured data is that a lot less text would be generated, which would need to be moderated. And also, LLMs can help us with constructing structured data, because something like a like is really simple. It can have a button. But for more complex structured data, we might need to talk to something in a natural language so that it can help us craft the specific objects which we need to then submit, which are then aggregatable. And so think about it. When you say something in social media, even if it goes viral, it is then forgotten, because it's viral only for a few hours, days, and whatever, and it then fades in time. It's ephemeral. But if you actually express what you mean with structured data, and that then becomes aggregated, and there was a count produced for all people who actually think that thing, that would not be, it would not fade in time this way. And also, later on, you can change your mind and change, your structured data, what you've said, and then that would be updated in the global count. And we all actually want to express our opinions, but currently we know that when we just spout out in social media, it's ineffectual. But this way, there will be a lot more effect and not ephemerality of what we say. And also, each aggregate can be computed many, many different times from different points of view, because I might decide to count only some votes, and or maybe with different weights. And later, we're going to see why we might want to do that. OK, so let's talk about annotation and duplication. So one goal within this ecosystem would be to have any concept, entity, or event to have a single unique identifier to which we can point to it. Because like in Wikipedia, there are many pages about many things, but there's only one page for any one thing. And we might have many different opinions about it, but still the thing is only one. And also in our heads, we have concepts only once in our head, but we might have many different opinions of our own about those things, and we might even house the opinions of others in our heads which relate to that thing, but still that thing is only one. There is one of it. And that's something which we need to replicate more in the web. And also, we should be able to ask questions like, has somebody or maybe anyone I follow said something specific about something specific? And for example, there's this page in Wikipedia about utilitarianism, and it has a criticism section. imagine if you could not just see what somebody decided to add there, but you could actually query, has anybody I follow ever expressed criticism of this idea? That would be really powerful. And so to achieve this, if we had the semantic web and even propositional logic and much more formality, that would be great. But it's not certain that we'll be able to do that, because defining ontologies which define all of the categories to describe all of the actions on objects from the real world is really, really hard to make that both usable and comprehensive. But still, it will be part of the whole picture, but it doesn't need to be 100% of the whole picture, because we can deal even with text and still deduplicate things. And perfect is the enemy of the good. So examples of where we've managed to deduplicate a lot of things, and we're still dealing with a lot of text, is Wikipedia, Stack Exchange, Quora, IMDb. And so we're already managing to deduplicate things with pure contributions. But we can actually add a lot more incentives for people to annotate data and to contribute annotations. Annotation might be, this is a duplicate of that. And so, for example, imagine if you annotate something and it's not contested by anyone for it being wrong, you get +1, like some point. But if somebody contests your annotation, then that can get escalated to a higher level of a hierarchy of moderators or annotators, more senior ones. And if they rule against you that what you annotated was wrong, you would get -3. So you have an incentive to actually annotate properly. And the good thing about annotation is that it's a lot more straightforward. Anyone can check if something matches something else. It's not trying to compute to say if something is true, only if something is similar to something else, which is a lot easier for anyone to actually see. And yeah, and also these incentives here are just a really, really simple example, but we can devise a lot more complicated ways to incentivize people to play nicely in an information ecosystem. Okay, but what about truthfulness, not just annotation? So fact-checking billions of people, turns out, doesn't really scale. But maybe annotating their claims and pointing those claims to the unique, deduplicated argument maps for those claims, and then trying to decide what's true only in one single unified place, maybe that scales. And think about it like m times n versus m plus n, because you only need to annotate things once, and then you only need to every concept to argue if it's true or not only once. Well, it's not going to be once because it's multi-perspectival, as we already said. You can have different rules to how something is calculated and reasoned about, but still, it's going to be one single place. And yeah. And so one other thing is that we can have something like a fact database, which is a bunch of propositions which we say that are true. And then we might use these fact databases to feed them into argument maps to compute what's the result of a bunch of arguments. But we might disagree with some facts from some database. So we might just fork it and just overwrite a few facts and then construct a new view of reality, and then use that new fact database to actually recompute all of the arguments for all of the things. And then with all of the annotations which people have made for all of the text which people have said, we might see, according to our view of what's true, to see who has said more true things, for example. Okay, the next thing I'm going to talk is relevance realization and sorting. And so, given the near infinite complexity of the world, the question is, how do we intelligibly ignore irrelevant information and zero in on what is relevant to us? And John Vervaeke says that relevance realization is at the core of general intelligence, because it's all about decision pruning in a combinatorial explosion. Like, if you really think about what your brain has to do to actually be a functional human being and orient in the world and have a conversation and to know what others mean and to think, that's incredible. Like how much just inconsequential things and irrelevant things are filtered out. And so one form of relevance realization in this new ecosystem could be sorted lists. Like, for example, I might express my top 100 values, or maybe not just personal values, but global values, which I think should be global, or 100 videos which I think everybody should watch, or my goals, or maybe global goals, or maybe my concerns, or global concerns, or books which I think everybody should read. And because this thing, top 100 of X, could also be structured data, and it could also be aggregated. And so we can actually each of us can express these things once, and then we can aggregate that and see what we collectively think should be viewed, should be researched, should be valued, or whatever. And we can again get those aggregates and recompute them in many different ways with different filters and criteria. And yeah, wouldn't you want to say that schools probably need to teach kids how money works, or maybe a little bit more about cognitive biases, or maybe that sugar is bad, as opposed to what types of soils, are somewhere. Like, I think this, at least I would like to be able to express that, and I think at least some people would also like to express that as well. And another kind of relevance realization is visibility templates. Like, what should be by default seen when you look at the concept or event or some entity. And here's one example. Like, suppose there's some event, and maybe an elected official and a normal person would need to know different things about that. Maybe a normal person just needs the overview, but maybe an elected official also needs to see what other elected officials see. And so we can define different templates for what should be by default visible when we're looking at something. And that's another way to actually filter what's relevant about something. And that's like a general principle which can be applied to anything. And so what we're trying to create here is PageRank 2.0, where we're not ranking web pages, but we're ranking identities and their reputation. And we're trying to compute that, and we're trying to make it multi-perspectival. And also, wouldn't it be nice if you could actually query instantly how much do I share with that other person without having to read everything they've ever said and try to think what they might have deleted or whatever. Everything which is still public by them, you could simply try to overlap and see how much you overlap and where your common ground instead of where you disagree directly. And so we could create computed history and computed identity. And think about it. Like, sometimes you hear something from a politician, and he says something, and you maybe like it, you resonate with it, and you immediately say maybe he's reasonable, but you have absolutely no clue about his previous positions, and maybe he was flip-flopping, maybe he was for 5 years doing something which is objectively not good. In this system, maybe you would be able to a lot easier think about these things and know with a glance against a certain set of rules what somebody actually thinks and how his thinking has evolved throughout time. And as an example of a PageRank for identities is the H-index for scientists, for example, because it's all dependent based on the number of citations. And they already have such ranking of scientists based on their contributions in the Open Commons. Okay, so a little bit about prediction markets. So a clever person solves the problem, a wise person avoids it. And I think that if you can provably and reliably predict the second and third order effects of policies and decisions, and you have superior modeling of the world, that you should be in charge. Or at least that should be one major factor about that. And also that we should try to make the accumulation of credibility, legitimacy, prestige, and power to be in public and to be incorruptible and to be verifiable by everyone according to objective standards. And also, we can create these prediction markets where people don't have to vote with money about the outcomes of things, because there have been many such attempts previously. And there are pros and cons to such prediction markets. But in this system, we can create a prediction market which is non-financial. It's purely based on reputation. What you have said at some point, what you have tried to predict about the future, or what opinion you have expressed about a certain point in time. Okay, so what does the brain do? Well, for agency requires making models of the future with causal simulations. We need to model what causes what in order to be an effective agent in the world. And what the brain does is it constantly generates and updates a mental model of the environment, and then it uses this mental model to predict the input signals which will come to it, and then later when the input signals come from the world, it compares what it predicted with what actually came, and then it adjusts the model. And so it uses Bayesian inference, or at least something sort of like it, where it's using the Bayes theorem for statistical inference to update the probability of a hypothesis as new information comes in. And this is really important. And this is how we should be thinking about prediction and what we need to be doing in the world. And truth is much too complicated to allow anything but approximations. We should always be thinking about approximations, and we should always be trying to view things from different perspectives and easily. Okay, so let's talk about programmable incentives. Like, humans are status-seeking monkeys, and you can take the monkey out of the status-seeking game, but you can't take the status-seeking out of the monkey. And so IMDb and Wikipedia, for example, they have harnessed the status-seeking and altruism of experts, but we can go a lot further in harnessing the altruism of people and their expertise, because we can actually incentivize it and bribe them or nudge them or whatever word you want to use to do tasks for us which we need, which we think we need doing. And we might give them higher voting power, maybe globally or maybe only on certain issues. We can decide that. And we can also decide how much higher. We can also give them a little bit of a recommendation boost in algorithms so that what they say can get a little bit more visibility. Or we can just put them in leaderboards and House of Fame, because and to make it more explicit that they have contributed a lot about something which needs the contribution. We need to incentivize it more. And also we can program many other rules, like, for example, there can be decay of reputation or status, because you don't want somebody to amass a lot of reputation initially and then have that forever. Maybe it has to decay, and they have to constantly work to keep it up and to be up in the leaderboard. We can tune how we weight all of these things. We can reward quickness, like how quickly do you come to a decision. Or we can also reward adaptation, how quickly you changed your mind from something which was wrong, according to us, of course, according to our fact database, to something which is correct. We can even tune that. We can even start betting on others by lending our status and saying, hey, I'm a high status person. I think that person will also be high status in the future, but they haven't proven themselves yet. But I'm giving them a signal boost right now because I think they will do good, for example. And that will be something which we'll be able to do in this system as well. And here's a quote by somebody really rich. Show me the incentive, and I will show you the outcome. So we need to incentivize what we want to see in the world. So let's talk about alignment, altruism, and what is that? Incentives. The elephant in the room when it comes to alignment is human alignment. So we talk about alignment of artificial intelligence, but we actually haven't solved alignment between humans. And so in this system, we'll be able to create an infinite number of new non-transferable points and currencies, which we can then let some people gift to others as recognition for what they have done. So this is another way to signal what we think, another way to surface who contributed the most and deserves the recognition. And this all can be transparent, so we can see if somebody is trying to boost someone nefariously, for example. Okay, and alignment requires incentive design for consequence capture. And what is consequence capture? Well, all agents must capture sufficient of the beneficial and harmful consequences of their actions on others. What does that mean? It means that if I'm an altruist, if I just expend resources and time and I don't get anything in return, I will simply be outcompeted by people who simply are not altruists. They don't have to be mean or bad. They simply don't need to expend resources and fall behind. So altruists need to get something in return for altruistic acts. And also, if you're cheating, there should be a penalty. Or if you're harming others, there should be a penalty. This is like a really, really simple and profound concept, which is actually biology and evolution have discovered it multiple times through different jumps in evolution. And in your body, think about it. All of the cells and the different organs, they're in complete harmony. And another quote, have I done something for the common good? Then I share in the benefits. Like, this is from somebody from really, really far behind in time. And another quote, the older the problem, the older the solution. So alignment is a really old problem, and evolution and biology and life have solved it multiple times, and we can learn from that. So let's talk about social influence score. So not credit score, influence score. And social credit score, well, it's top-down rules, it's non-participatory, it's about taking rights away, it's about closing doors. But social influence score is about bottom-up rules, which we can define what the rules should be. It's participatory, it's about granting more and more influence, and it's about opening doors. and we can start trying solving collective action problems in this ecosystem. So we can start trying to bribe or nudge entire organizations to do what we want. Like, for example, what we might demand, like more open source, more open patents, and more data just provided to the commons. We might try to demand that they don't engage in planned obsolescence, or maybe not to engage in multipolar traps. Like, for example, one social media starts using a recommendation algorithm which just sucks your attention, which is time spent, but it's not time well spent, and immediately other companies, if they don't do the same psychologically exploitative tactic, they will fall behind in terms of ad revenue and attention, and so they do it as well. And that's a multipolar trap. And we should try to actually solve this and incentivize companies to not play along in these games. And also, maybe we might want them to account better for the externalities and how they exploit the commons. And how might we actually bribe them and nudge them? Well, we can reward companies with boosts in the recommendation algorithms so that their marketing budget could be a lot smaller, or maybe even zero. We might put them higher in leaderboards and point them to by default if they actually have done all of the things which we think any company should be doing. And they can become the default that we choose simply by doing what we all think should be done. We can even give higher career rank to the employees which work at that company so that there's also not just an incentive for the company, but also for the employees to choose such companies. And I think that we really should try to penalize companies for exploitation, even though that's really broad. So what's liquid democracy? So direct democracy is where you can vote, and you should vote, or at least can vote, on every issue. But that doesn't really scale, because it's just too much work, and you have to learn about too many things. What we have today is representative democracy, where we actually vote on representatives, and they vote on our behalf on issues. But liquid democracy is a scheme which is enabled by the internet, where we can actually split our votes, and we can vote on certain issues directly, because we either have the expertise, or we just really feel very strongly. And on other issues, we can delegate to someone else. And that someone else, they can even delegate to someone else, because, and we might even trust them that they will delegate properly to someone else. And that's absolutely valid, and that allows a lot more fluidity and nuance. And one thing which I don't think anybody has said is that we can even use liquid democracy not just to vote on things, but even to inherit settings, like what recommendation algorithm somebody is using. And here's something. So democracy and nation states in their current form, they were conceived when we used to send paper letters by horse. And we're still using that social operating system. So the design space for social media is really vast. And I think that TikTok, Facebook, and Instagram are just scratching the surface. And I think we can tune any knob of social media and put it to a vote. For example, we might decide to put psychologists behind what and how recommendation algorithms work. Well, currently there are psychologists, but their incentives are a little bit misaligned. We can have competing views and states of the same events, of the same data. And we can experiment on every level of the layered stack of incentives and see, like within a few months or within a few years, which view does better. It either makes its people more happy, or maybe it predicts the world better. And then, again, after a fork, after we see which is better, it can merge again, and we can pick the winner. And so what we're trying to create here is a new competitive landscape that is not tied to money and resources, but to status. And we can engineer all kinds of new signals, like for bias, for clickbait, for loaded language, for missing citations, and many, many, many other things. Like, it's vast. And we can even create anonymous polling, where we can have provable credentials about something, but still people can have anonymous polls and see what they think. Like, for example, wouldn't you want to know what doctors really think without the threat of being fired, for example? I think that's something which society should be able to do. And as I said in the liquid democracy slide, we can have automated or implicit or inherited influence. Like, how do I view the world, what recommendations or settings I use. And for that, you don't need to explicitly follow what somebody has to say, and if they have recommended something, you can just inherit it. And so what we're trying to create here is a global participatory social operating system with identity and incentive design as the foundation, and trying to give rise to something like a better meritocracy compared to what we have right now. And so if this all sounds like spaghetti, like a lot of data and connections and different views, well, look at the neural connectome. And this is actually sparse. This is not a full connectome. This is just some neurons. The full connectome is absolutely packed. There is no free space. And that's what's going on in your brain. And the brain is not defined by the knowledge or even the distribution of knowledge. It's defined by the interconnectedness, the connectome. And so actually, you and every single one of us is a neuron. And think about it. You read articles. You talk with your colleagues, you receive information, you watch the news, you browse social media, and then you spend your dollars. That's an output signal, what you choose to do. You produce content on social media, you do work in your company, and you do your job. You also, even when you do a search query, you're actually affecting Google's algorithms and everybody else with your search. Or when you click on a recommended video, you help Google and YouTube tune their recommendation algorithm. And that's, again, an action from you which actually influences everybody else. And that's what neurons do. They take information and signals in, and they then put information signals out. And so I guess you've heard about transformers and large language models, and the paper which introduced them was titled "Attention is all you need," but I also say that attention is all you have. And that's why we say that we pay attention. It's a resource. It's like time is the only true currency. That's why we put rich people and poor people in jail, because time is the most, and attention, they're the ultimate currency. And so I want to tell you a bit about availability cascades. I think that's a really, really important idea. And so it's made of availability and cascades. And the availability bias part is the perceived likelihood of any given event is tied to the ease with which its occurrence can be brought to mind. So the more you hear about something and the easier it is for you to bring it to mind, you either think it's more true, or it's more easy for you to think about it and to even express it to others. And because it's a lot more easy for you to express it to others, that's how that can trigger a social cascade. And once something becomes more available to you, and then you start creating it more available to everybody else, and suddenly everybody's talking about it. And the key thing about availability cascades is that the importance and the availability, they don't have to match. Like, many important topics never trigger cascades, and many unimportant topics do trigger cascades. And I think we should be thinking, how do we fix it, at least partially? And another thing is that there are many availability entrepreneurs who are agents with an agenda trying to trigger a cascade. Sometimes the agenda is good or it's bad. And these agents can be governments, media organizations, companies, and even individuals. Like, it's currently an all-out information war on every aspect of in society. And so let's talk about attention schema theory. The theory begins with attention, the process by which signals compete for the brain's limited computing resources. This internal signal competition is partly under a bottom-up influence and partly under top-down control. We propose that the top-down control of attention is improved when the brain has access to a simplified model of attention itself. The brain therefore constructs a schematic model of the process of attention, the attention schema, in much the same way that it constructs a schematic model of the body schema. And so let's talk about the body schema. Like, if somebody has their leg amputated, God forbid, they might have the phantom limb syndrome for many, many, many months after that, where they still feel sensations in something which is not even there yet. So that is their model of their body, which is still not completely updated. And the same way, we have an attention schema. And this attention schema is used to control our attention, to model the attention of others, and to also inspect our own attention. And I want to ask, do we have access to our data and attention altogether, how we're spending it on big social media? And no, we don't, because who can see and guide our attention on Facebook and Twitter? Well, it's only the data scientists, project managers, and in the companies. And that's an asymmetric relationship. They guide the attention of humanity only for their own benefits. And I think that we should all be able to have a say how that happens. Because if we want to be at least partially more, conscious globally. Let's talk about integrated information theory. But actually, we're not going to talk about it, because it's very long. But let's talk about integrated information. I think that's the really nice part of that theory. And here are a few questions. How do we deduplicate all entities, events, concepts, and questions, and make it possible to query for everything that points to X and filter it however we like? That's a form of integration. How do we rank and topologically sort all of the most important issues in the world and see what needs to be done before what and what affects what, and create causal maps? That's again a type of integration. How do we reduce the time from discovery or consensus on an issue to having that information be distributed to all of the parties which are affected or should be affected? How do we wire that, and how do we make it so from the point of discovery or change, that change trickles down to all affected parties, or at least all that should be affected? That's again a type of integration, I think. And like, what is our civilization objective? Do we even have one? What do we value? Do we have a unified voice? I don't think we're coherent at all. And where are the global dashboards and global KPIs which we want to track and solve? And keep in mind that all of this software and this incentive design and all this thing, it can be actually applied not just globally, but also on a national level, but also in a company level. You can use the same set of argument maps and the duplication and incentives and whatever and voting on different levels. Like the same software, the same. Think about it like you had to learn how to use Excel only once. And in this system, you're going to have to learn how this whole thing works only once, and then you can apply it in any way. Because I think this is the most superior way to gather collective intelligence. And yeah, so let's continue with reading quotes from the slides. There's this great paper called All Intelligence is Collective Intelligence. And so the structure and development of the brain is characterized by highly efficient and robust mechanisms of competition, cooperation, consensus building, and dynamic reconfiguration of neural coalitions. The intelligence of brains is due not to precisely designated designed neural circuits that implement specific computations, but instead due to an intrinsic capacity for collections of neurons to spontaneously organize in service of the group. The dynamic reorganization of functional subnetworks in the brain and the massive interactivity is taken into account that effectively forms an effective committee for each task on the fly. And humans may have much to learn from neurons about constructing harmonious societies. So, metasystem transitions. So they have happened. There have been 3 broad metasystem transitions, which have resulted in 3 broadly defined levels of higher control, producing 3 broadly defined levels of group selection: tribes, kingdoms, and nations. And it was each time thanks to a new and more powerful information processing medium: language, writing, and the printing press. And now we have the internet, and we still haven't truly utilized it in its full potential. And nation states, they were never built for global action. They're obsolete for the problems which we need to solve. And I think that it's all about information and communication at the end. And these are 3 quotes which I really love. And especially the medium is the message. Like, it's not so important what the message is, but what is the medium through which messages pass. That's what we should be studying and thinking about the most. How do we optimize it? And in the long run, history is the story of information becoming aware of itself. So, what is the global brain? I'm almost done with the quotes. The global brain is the emerging intelligent network that is formed by all people on this planet together with the computers, knowledge bases, and communication links that connect them together. Like a human brain, this network is an immensely complex, self-organizing system that processes information, makes decisions, solves problems, learns new connections, and discovers new ideas. It plays the role of a nervous system for the whole of humanity. No single person, organization, or computer is in control of this system. Its thought processes are distributed over its all components. So this is not about AI, it's about collective intelligence. Yeah. And so this is our story so far. We've always been a bunch of monkeys which are connected with within a really, really complex adaptive system. But I think that we really, really should be thinking about this and to push it to the extreme and to actually learn from nature. And Stephen Hawking said it. The next century will be the century of complexity. We're not going to have this time for these quotes. And so this idea, so far, this presentation contains just 1 or few % of the whole thing. I have a lot of chaotic notes, which I'm going to still continue to accumulate. Then I'm going to write a book. I'm going to release next year. And then I'm going to try to build this whole thing. And that's it. Any questions? We have 3 minutes.
Thank you very much, Victor, for a really, really insightful presentation and a great idea for the democratic internet. So this is the time for question and answers. So if you have any question, then please raise your hand and ask it.
Is it working? Yeah. At the beginning of your presentation, you said that this whole system would rely on a single identifier for a person. So would you consider it a like security hazard in scenarios you showed us in the presentation? You said that it would all gather in a score, but if someone would steal this identifier and use it maliciously, it would result in a big, like a collapse of rating. So how would you say it would affect it?
Well, yeah, but we'll be able to own our identities with a public and private key. And we also won't need the private key to use the system. And so by default, you're not going to use the private key, so it can be in cold storage on a piece of paper under your mattress where nobody can get it. And only if something wrong goes, then you can use this key to recapture your own identity. So that's one part of the issue. But the other part of the issue is that, yes, data can leak, for example, private things. But that's the same with the current system. Like somebody can hack Google, and the level of the security and the issues will be the same, I think. And I think this is like an upgrade, because you cannot own your email or your domain name or your account on any social media the way that you would be able to own your account in this system, because here you will be able to own it with a key pair. But another crucial thing is that you don't need a public and private key to actually own your account. So by default, you can just create an account, and at any point in time, you can bind the private key and the public key to it. And even after you have bound the private and public key, you still don't need to use them on a daily basis. So it would still feel like the normal internet of right now. Any other questions? Order.
Hey, hello. So I was watching your presentation here, and it really reminds me what Gavin Wood said a few months before about Polkadot 2.0. Do you see any similarities? Because I see pretty much.
I have absolutely not paid attention to Polkadot. I've just put it aside, but maybe I should look at it. Because he's an interesting person. Like, I don't really believe in Polkadot, for example, but I should see what he has to say, definitely. Thank you for pointing that out.
I also have one question.
Okay.
So on the beginning, I wanted to ask if you are going to create such system, and you answered this question. So my question is, what plan do you have for this, creation of such initiative?
Well, I just want to try to get all these thoughts into a coherent form, because then a conversation can start, because this is absolutely not sufficient. Like, there are so many holes in this presentation, so many things sort of partially fit, but they cannot convince everyone. And also there are so many details which are left out, and there are also so many details which even I don't still have. And so I think that there should be a really, really comprehensive plan how this whole thing could work. And then the next steps would be, fundraising, teams, building the core of it, which is the blockchain, and then building a bunch of infrastructure. Like, I think that the next Google would be built on top of this address space, which this system would enable.
Okay, thank you and good luck.
Thank you. I know it sounds easy.
How does your scenario covers the right to being forgotten?
In this ecosystem, when you decide to purge something, it's not going to be on the blockchain, but it would still be cryptographically bound to it. And once you create a purge request, all entities which are in jurisdictions which honor that, they will have to delete it. But anybody would still be able to actually keep a copy, which will forever be cryptographically bound. And they'll be able to prove that you said that in the past. And while that has downsides, I also think that it has upsides, because I think that the higher you go up in power, the more accountability there should be for you. And also in this system, there can be different types ways to address data. And only one type of addressing data would be cryptographically bound, like I'm saying. But there would be another model which would be like the host-centric model like right now, where you would be truly able to be forgotten. But I think that everything which relies on prediction markets and policies, that it should be in the address space where nothing can be forgotten. So that even one person can save a copy of something and later in the future prove that somebody said something.
Thanks. Okay, so it was a great presentation. Thank you.
Thank you.
It was amazing. My question is, let's say such system was actually being implemented. My question is, what would the plan to convince average citizens to the new system look like?
Well, I think it's going to take a long, long time. But initially, imagine like 100,000 people start using this. And these are, people who currently use Twitter, but it is really, really lacking in so many respects to actually surface signal. It's doing sort of a good job. It's the closest thing we have to a global consciousness right now. But it can be so much better. And some people will jump to this ship, and time will pass. They will, construct the best filters for how to filter information, signal from noise. They will start discovering faster who is better at predicting things, and people will start talking. And people who actually really want to be close to the edge, to what's actually going on and to what's actually going to happen, they will naturally gravitate to these systems. And this system at one point will have maybe a few million, then 10 million, 20 million, 50 million. And also, this system, you can also create Instagram in it. Like, you can also just create a simple app where you just share pictures. And so it can be used by anyone. But I think that the most interesting part is this sense-making architecture, which is going to appeal initially to a really small fraction, but yeah. So gradually and then suddenly,
Thank you very much, Victor, for your presentation.
Oh, thank you. Oh, yeah. Thank you.
And good luck.
Well, thank you.
So we will keep our fingers crossed. So thank you very much, everybody, for participating in the 10th Code Dive edition. While there's no official after party, we can all meet at Kontynuacja. It is in the city center in Rynek, just like in the last year, for a casual gathering. Thank you once again. You can now proceed to room number 1 to find out the winner of our contest. Thank you.